So good morning, welcome you all. Previous session ಅಲ್ಲಿ inverse trigonometric functions problems na discuss ಮಾಡ್ತಾ ಇದ್ದೆ. So ಇವತ್ತು ಅದನ್ನ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೀನಿ. I think ಇವತ್ತು ಈ ಚಾಪ್ಟರ್ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ. ಒಂದು 5-6 ಸಮ್ಸ್ ಇದೆ ಅಷ್ಟೇನೆ, ರೈಟ್? ಸೊ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಏನು ಬೇಕಿಲ್ಲ, ಇಂಟ್ರಡಕ್ಷನ್ ಏನು ಬೇಕಿಲ್ಲ ಅನ್ಸುತ್ತೆ. ಡೈರೆಕ್ಟ್ ಆಗಿ ಸೊ ಪ್ರಾಬ್ಲಮ್ಸ್ ನ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. ನೋಡಿ, ನೆಕ್ಸ್ಟ್ ಸಮ್ ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದೆ, ರೈಟ್? tan inverse of x by root of a square minus x square in the simplest form. Okay, so write tan inverse of x by root of a square minus x square in the simplest form. ಈ ಫಂಕ್ಷನ್ ಅನ್ನ ಸಿಂಪ್ಲೆಸ್ಟ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬೇಕು, ರೈಟ್? ಈ ಫಾರ್ಮ್ ಅನ್ನ ಸಿಂಪ್ಲೆಸ್ಟ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಸೊ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮೆಥಡ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ಕೊಬೇಕು. ಸೊ ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ a square minus x square, ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ 1 minus x square. ನಾನು ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಹೇಳಿದ್ದೆ, ಬೇಸಿಕ್ ಐಡೆಂಟಿಟಿಗೆ ರಿಲೇಟ್ ಮಾಡಿ 1 ಪ್ಲಸ್ sin square theta plus cos square theta is equal to 1. Cos square theta is equal to 1 minus sin square theta, or sin square theta is equal to 1 minus cos square theta. You can write like this also. Again, cos theta is equal to root of 1 minus sin square theta. So function nimge root of 1 minus x square form ಅಲ್ಲಿ ಏನಾದರೂ ಇದ್ರೆ x ಇರ ಪ್ಲೇಸ್ ಅಲ್ಲಿ sin theta ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ 1 plus x square ಅಂತ ಏನಾದರೂ ಇದ್ರೆ x is equal to tan theta, ಸೆಕೆಂಡ್ ಐಡೆಂಟಿಟಿ, ಬೇಸಿಕ್ ಐಡೆಂಟಿಟಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅಥವಾ x square minus 1 ಇದ್ರೆ x is equal to secant theta ಅಂತ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಪ್ರೀವಿಯಸ್ ಸಮ್ ನಾವು ಸಾಲ್ವ್ ಮಾಡಿರೋದು x square minus 1 ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದೆ, ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಅದನ್ನ. ಓಕೆ, we have taken x is equal to secant theta. So here this is of the form 1 minus x square. 1 minus x square means put x is equal to sin theta, right? So in addition to that means in place of 1 here we have a square. A square is there, so include that one in solution part. I don't write put let x is equal to a sin theta. X is equal to, so here we have a square ಇದೆ, ಹಾಗಾಗಿ a ನ ಇನ್ಕ್ಲೂಡ್ ಮಾಡಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ತಗೊಳ್ತೀನಿ. x is equal to a sin theta. So then it's an inverse function. Theta is equal to, first cross multiply a. Sin theta is equal to x by a. You will get sin theta is equal to x by a. So theta is equal to sin inverse of x by a, right? If x is equal to a sin theta, then theta is equal to sin inverse of x by a, right? So now tan inverse of x by root of a square minus x square, which is equal to tan inverse of, so numerator x means a sin theta by square root of a square minus a square sin square theta, right? So x ಇರ ಪ್ಲೇಸ್ ಅಲ್ಲಿ a sin theta ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. ನ್ಯೂಮರೇಟರ್ a sin theta, ಡಿನಾಮಿನೇಟರ್ square root of a square minus x square minus a square sin square theta, right? Again, which is equal to tan inverse of a sin theta divided by square root of a square minus a square sin theta is there. We can take a square as common. A square na common ಆಗಿ ಬರ್ಕೊಳ್ಳಿ. So remaining term 1 minus sin square theta. Remaining term 1 minus sin square theta. 1 minus sin square theta can be written as cos square theta, right? A square minus a square sin square theta ಇದೆ. A square ನ ಕಾಮನ್ ತಗೊಳ್ಳಿ ಫಸ್ಟ್, 1 minus sin square theta ಆಗುತ್ತೆ. 1 minus sin square theta na cos square theta ಅಂತ ಬರ್ಕೊಂಡಿದೀವಿ. Again which is equal to tan inverse of a sin theta by a square cos square theta na root in the outside ಬರ್ತೀವಿ. You will get a cos theta form ಆಗುತ್ತೆ. Right? Again next step ಅಲ್ಲಿ a cancel ಆಗುತ್ತೆ. Again which is equal to tan inverse of a cancel ಮಾಡಿ sin theta by cos theta. We can write tan theta, right? Tan inverse of tan theta again which is equal to theta. Then conditions ಎಲ್ಲ ಏನು ಡಿಫೈನ್ ಮಾಡಿಲ್ಲ. ಸೊ ಅದು tan inverse of tan theta ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ ಅದು ಅಂಡರ್ಸ್ಟುಡ್ theta within the domain ಅಲ್ಲೇ ಇರುತ್ತೆ. ಸೊ ಹಾಗಾಗಿ tan inverse of tan theta which is equal to theta. So theta means inverse function ಗೆ ಚೇಂಜ್ ಮಾಡಿದೀವಲ್ಲ ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. That is sin inverse of x by a. So don't write down 1 by a sin inverse x. ಆ ತರ ಬರಿಬೇಡಿ. Actually first a ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಆಮೇಲೆ ಇನ್ವರ್ಸ್ ಚೇಂಜ್ ಮಾಡಿದ್ವಿ. ಯು ಶುಡ್ ನಾಟ್ ರೈಟ್ sin inverse x ಅಂತ ಬರ್ಕೊಂಡು a ನ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಕ್ ಹೋಗ್ಬೇಡಿ. 1 by a sin inverse x ಆ ತರ ಬರಿಬಾರ್ದು. theta is equal to sin inverse of x by a. Okay. So tan inverse of x by root of a square minus x square na simplest form sin inverse of x by a. Okay. So write down this thing. Next number ಕೊಡಿ. So ತುಂಬಾ ಈಸಿ ಆಗಿರೋ ಕಾನ್ಸೆಪ್ಟ್ ಬಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ಸ್ ಅನ್ನ ಕರೆಕ್ಟ್ ಆಗಿ ನೋಡ್ಕೊಬೇಕಷ್ಟೇ. ಸೊ 3 ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ಸ್ ಬರುತ್ತೆ ಯೂಶುವಲ್ ಆಗಿ sin theta, tan theta, secant theta. sin theta ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಬರಬೇಕಾದ್ರೆ ಫಂಕ್ಷನ್ ಯಾವಾಗಲೂ ಅಷ್ಟೇ 1 minus x square or root of 1 minus x square. ಸೊ ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಫಂಕ್ಷನ್ಸ್ ಇರುತ್ತೆ. x is equal to sin theta. Suppose 1 plus x square or 1 plus x square or you can have root. ಈ ಫಾರ್ಮ್ಸ್ ಅಲ್ಲಿ ಏನಾದರೂ ಇದ್ರೆ ಫಂಕ್ಷನ್ x is equal to tan theta ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ತಗೊಬೇಕು. ಬಿಕಾಸ್ ಬೇಸಿಕ್ ಐಡೆಂಟಿಟಿ ರಿಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ 1 plus tan square theta ಅಂತ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. 1 plus tan square theta. So here 1 minus sin square theta or 1 minus cos square theta ರಿಲೇಟ್ ಆಗುತ್ತೆ. Okay. So next root of x square minus 1 or x square minus 1 ಈ ಫಾರ್ಮ್ಸ್ ಅಲ್ಲಿ ಏನಾದರೂ ಬಂದಿದೆ ಅಂದ್ರೆ ಯೂಶುವಲ್ ಆಗಿ ಓಕೆ x ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ secant theta ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀವಿ. ಬಿಕಾಸ್ secant square theta minus 1 ಅನ್ನ tan square theta ಅಂತ ಹೇಳ್ತೀವಿ. ಹಾಗಾಗಿ ಈ ಮೂರು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ತಿಳ್ಕೊಂಡಿರ್ಬೇಕು. ಪ್ಲಸ್ ಇದೆ ಅಂದ್ರೆ x is equal to tan theta, ಮಧ್ಯದಲ್ಲಿ ಮೈನಸ್ ಇದೆ ಅಂದ್ರೆ x ಯಾವ ಸೈಡ್ ಇದೆ ನೋಡ್ಕೊಳ್ಳಿ. 1 minus x square ಇದ್ರೆ x is equal to sin theta, x square minus 1 ಇದ್ರೆ x is equal to secant theta. In addition to that ಈ 1 ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಸಪೋಸ್ ಬೇರೆ ಯಾವ್ದಾದ್ರು ಕಾನ್ಸ್ಟೆಂಟ್ ಇದ್ರೆ ಲೆಟ್ ಇಟ್ ಬಿ a. ಸೊ ಈ ಸಮ್ ಅಲ್ಲಿ a ಅಂತ ಇದೆ. ಸಪೋಸ್ ಈ 1 ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಬೇರೆ ಯಾವ್ದಾದ್ರು ಕಾನ್ಸ್ಟೆಂಟ್ ನಂಬರ್ ಏನಾದ್ರು ಇದ್ರೆ ಆ ನಂಬರ್ ನ ಇನ್ಕ್ಲೂಡ್ ಮಾಡಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ತಗೊಳ್ಳಿ. ಸೊ a ಸ್ಕ್ವೇರ್ ಇದೆ ಪುಟ್ x is equal to a sin theta ಅಂತ ತಗೊಳ್ತೀನಿ. ಸಪೋಸ್ ಇಲ್ಲಿ a ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಇರುತ್ತೆ ಅನ್ಕೊಳ್ಳಿ. a ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಅಂತ ಏನಾದ್ರು ಇದ್ರೆ x is equal to a tan theta. ಸೊ ಹಿಯರ್ ಆಲ್ಸೋ x square minus a square ಇರುತ್ತೆ. If we have x square minus a square, put x is equal to a secant theta. ಇಲ್ಲಿ ಯಾವ್ದಾದ್ರು ಕಾನ್ಸ್ಟೆಂಟ್ ಇದ್ರೆ ಆ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನ ಇನ್ಕ್ಲೂಡ್ ಮಾಡಿಕೊಂಡು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಅನ್ನ ಬರಿಬೇಕು. ರೈಟ್? So next one, write tan inverse of root of x square minus 1 divided by x in the simplest form. ಅದನ್ನ ಸಿಂಪ್ಲೆಸ್ಟ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಆಸ್ ಯೂಶುವಲ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಅನ್ನ ಮೆನ್ಷನ್ ಮಾಡಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ರೈಟ್? So let x is equal to, so here I will write secant theta. Okay, x is equal to 1 minute. So problem is like this. Sorry, problem 1 plus x square tan inverse of square root of 1 plus x square minus 1 divided by x. So yeah, 1 plus x square is there. 1 plus x square is there. Let x is equal to tan theta. Substitution is x is equal to tan theta. So then, if x is equal to tan theta, then theta is equal to tan inverse x. Right? If x is equal to tan theta, then theta is equal to tan inverse x. Now, tan inverse of square root of 1 plus x square minus 1 divided by x, which is equal to tan inverse of square root of 1 plus tan square theta. So write in place of x tan theta. You get tan square theta minus 1 divided by tan theta. Right? So x place alli tan theta anta substitute ಮಾಡಿದೀವಿ. Next, it's a simplification. Tan inverse of 1 plus tan square theta secant square theta root of secant square theta, that can be done as secant theta. Right? So 1 plus tan square theta is secant square theta. Root of secant square theta, secant theta. Secant theta minus 1 divided by tan theta. Again, this is equal to tan inverse of secant theta can be written as 1 by cos theta. Use reciprocal relation. Okay, reciprocal relation ಅನ್ನು ಯೂಸ್ ಮಾಡಿದ್ರೆ secant theta can be written as 1 by cos theta. 1 by cos theta. In the denominator we have tan theta. Tan can be written as sin theta by cos theta. Sin theta by cos theta, quotient relation. Okay, so secant theta we have written 1 by cos theta, tan theta sin theta by cos theta. Right? Again, which is equal to tan inverse of, if you take cos theta as LCM, you will get 1 minus cos theta divided by cos theta whole divided by sin theta by cos theta. Okay, I have taken in the numerator cos theta as LCM, 1 minus cos theta by cos theta whole divided by sin theta by cos theta. Again, which is equal to tan inverse of, okay, cos theta cancel ಮಾಡ್ಕೊಳ್ಳಿ. You will get 1 minus cos theta by sin theta. Tan inverse of 1 minus cos theta divided by sin theta. Again, which is equal to tan inverse of 1 minus cos theta. Submultiple angle ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡೋಂತ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿ 1 minus cos theta can be written as 2 sin square theta by 2. 1 minus cos theta is equal to 2 sin square theta by 2. ಆ ಫಾರ್ಮುಲಾವನ್ನ ಬಹಟ್ ಮಾಡ್ಕೊಂಡಿರಬೇಕು. So 1 minus cos theta na 2 sin square theta by 2 ಅಂತ ಹೇಳ್ತೀವಿ. Again, sin theta means 2 sin theta by 2 into cos theta by 2. Okay, so this is also submultiple angle formula. Sin theta, actually multiple angles ಅಲ್ಲಿ sin 2 theta ಅಂತ ಹೇಳ್ತೀವಿ. Sin 2 theta is equal to 2 sin theta into cos theta. Sin 2 theta is equal to 2 sin theta into cos theta. In submultiple angles, sin theta can be written as 2 sin theta by 2 into cos theta by 2. Just we have replaced in place of 2 theta, theta. Okay, you will get 2 sin theta by 2 into cos theta by 2. Again, which is equal to tan inverse of tan inverse of 2 ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, sin theta by 2 ಒಂದು ಫ್ಯಾಕ್ಟರ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. You will get sin theta by 2 divided by cos theta by 2. Okay. So tan inverse of sin theta by 2 divided by cos theta by 2. Again, which is equal to tan inverse of sin by cos. Sin by cos tan ಆಗುತ್ತೆ. So tan inverse of tan theta by 2. Tan inverse of tan theta by 2. Again, which is equal to theta by 2. Okay. By using property, so ಇಲ್ಲಿ ಯಾವುದು ಕಂಡೀಷನ್ಸ್ ಇಲ್ಲ, ಅದು ಅಂಡರ್ಸ್ಟುಡ್. ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಕಂಡೀಷನ್ಸ್ ಇರುತ್ತೆ. theta within the domain ಇರುತ್ತೆ. tan inverse of tan theta by 2 which is equal to theta by 2. Last step again, which is equal to 1 by 2. So theta means tan inverse x. Tan inverse x is that 1 by 2 tan inverse x. So this is the simplest form of the given function. Tan inverse of root of 1 plus x square minus 1 divided by x. ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇರುವಂತ ಫಂಕ್ಷನ್ ಗೆ ಸಿಂಪ್ಲೆಸ್ಟ್ ಫಾರ್ಮ್ ಏನು ಅಂದ್ರೆ 1 by 2 tan inverse x. ಓಕೆ. ಸೊ ಮೆಥಡ್ ಆಫ್ ಸಾಲ್ವಿಂಗ್ ಏನು ಚೇಂಜಸ್ ಇರಲ್ಲ. ಫಸ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಏನು ಅಂತ ನೋಡ್ಕೊಳ್ಳಿ, ಆಮೇಲೆ ಕೆಲವು ಫಾರ್ಮುಲಾ ರಿಲೇಟ್ ಆಗಿದೆ ಅಷ್ಟೇ. ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್. ಸೊ ಇನ್ ದಿಸ್ ಹೋಲ್ ಫಂಕ್ಷನ್ ವಿ ಹಾವ್ ರೂಟ್ ಆಫ್ 1 plus x square. 1 plus x square ಇದೆ ಅಂದ್ರೆ ಅಂಡರ್ಸ್ಟುಡ್ x ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ tan theta ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ತಗೊಬೇಕು. ಓಕೆ. ಹಾಗಾಗಿ ಲೆಟ್ x is equal to tan theta ಅಂತ ತಗೊಳ್ತೀವಿ. tan theta ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ತಾ ಹೋಗಿ ಅದರ ಸಿಂಪ್ಲೆಸ್ಟ್ ಫಾರ್ಮ್ ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ದಟ್ ಇಸ್ 1 minus cos theta divided by sin theta. ಸಬ್ ಮಲ್ಟಿಪಲ್ ಆಂಗಲ್ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿ ಅಗೈನ್ ಅದರ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಬರೀರಿ. tan theta by 2 ಬರುತ್ತೆ. tan inverse of tan theta by 2 can be written as theta by 2. So theta by 2 ನ 1 by 2 tan inverse x ಅಂತ ಬರೀಬಹುದು. ಓಕೆ. ಸೊ ರೈಟ್ ಡೌನ್ ದಿಸ್ ಥಿಂಗ್. ಇಷ್ಟನ್ನು ಬರ್ಕೊಳ್ಳಿ ಹಾಗೆ. Okay. So next sum. Write tan inverse of 3a square x minus x cube divided by a cube minus 3ax square. It is the simplest form. So ಇದನ್ನ ಸಿಂಪ್ಲೆಸ್ಟ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬೇಕು. ಸೊ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಫಸ್ಟ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಎಕ್ಸ್ ಅಲ್ಲಿ ಇದೆ. ಇದರ ಸಿಂಪ್ಲೆಸ್ಟ್ ಫಾರ್ಮ್ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಿ ಅಂದ್ರೆ ಎಕ್ಸ್ ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ತಗೊಬೇಕು. ಐ ಥಿಂಕ್ ಇದು ಯಾವುದೇ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫಾರ್ಮುಲಾನ ರಿಲೇಟ್ ಮಾಡಲ್ಲ ಅನ್ಕೊಂಡಿದ್ದೀನಿ. ಆಕ್ಚುಲಿ tan ಇನ್ವರ್ಸ್ ಆಫ್ ಇಲ್ಲಿ ಟರ್ಮ್ಸ್ ಇದೆ ಅಂದ್ರೆ ಯೂಶಲಿ ವಿ ರಿಲೇಟ್ ಲೈಕ್ ದಿಸ್. ದಟ್ ಈಸ್ tan ಇನ್ವರ್ಸ್ ಆಫ್, ಐ ಥಿಂಕ್ ದಿಸ್ ಒನ್ ಈಸ್ ಅ ಪ್ಲಸ್. One second. Minus the sin x. Okay, so tan inverse of 3a square x minus x cube divided by a cube minus 3ax square. Right? again which is equal to, so here we have a cube ಇದೆ. ಸೊ a cube ಇದೆ ಅಂದ್ರೆ ನ್ಯೂಮರೇಟರ್ ಮತ್ತೆ ಡಿನಾಮಿನೇಟರ್ ನ a cube ಇಂದ ಡಿವೈಡ್ ಮಾಡ್ತೀವಿ. ಬಿಕಾಸ್ ನಮಗೆ ಫಾರ್ಮುಲಾ ಇರೋದು tan inverse of x plus y divided by 1 minus xy. ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ ಸೊ ಹಿಯರ್ ವಿ ಮಸ್ಟ್ ಹ್ಯಾವ್ 1 ಅಂತಲೇ ಇರಬೇಕು. ಹಾಗಾಗಿ ದೇರ್ ಅಲ್ಲಿ ನಾವು ಈ ರಿಲೇಷನ್ ಕಂಪೇರ್ ಮಾಡಬೇಕಾದ್ರೆ 1 ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ a ಕ್ಯೂಬ್ ಇದೆ. ಸೊ 1 ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ a ಕ್ಯೂಬ್ ಇದೆ ಅಂದ್ರೆ ಜಸ್ಟ್ a ಕ್ಯೂಬ್ ಇಂದ ಡಿವೈಡ್ ಮಾಡ್ತೀವಿ. ಸೊ a ಕ್ಯೂಬ್ ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ಸೊ ಯು ವಿಲ್ ಗೆಟ್ tan inverse of 3a square x minus x cube whole divided by a cube. ಬೇಡ. ಸೊ ಇದು ಒಂದೊಂದು ಮೆಥಡ್ ಒಂದೊಂದು ಬೇಡ. ಸೊ ಹೀಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮೆನ್ಷನ್ ಮಾಡ್ಬಿಡ್ತೀನಿ. ಜಸ್ಟ್ ಆಸ್ ಯೂಶುವಲ್ ಇದೇ ಫಾರ್ಮಲ್ಲೇ ಬರ್ಕೊಂಬಿಡಿ ಬೆಸ್ಟ್. ಲೆಟ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎ ಟ್ಯಾನ್ ಥೀಟಾ. ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎ ಟ್ಯಾನ್ ಥೀಟಾ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಈ ಫಾರ್ಮಲ್ಲಿ ಪ್ರಿಯಸ್ ಅಂಶ. ಇಲ್ಲಿ ಎಗೆ ಎಕ್ಸ್ಗೆ ಎ ಇನ್ಕ್ಲೂಡ್ ಆಗಿದೆ ಅಂದ್ರೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಬರಿಬೇಕಾದ್ರೆ ಎನ ಇನ್ಕ್ಲೂಡ್ ಮಾಡಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ತಗೊಂಡ್ಬಿಡಿ. So put x is equal to, or let x is equal to a tan theta. Again that implies theta is equal to tan inverse of x by a. Theta is equal to tan inverse of x by a. So now tan inverse of 3a square x minus x cube divided by a cube minus 3ax square, which is equal to tan inverse of 3a square. Here x is there. X means a tan theta. X in a place only a tan theta substitute ಮಾಡಿ minus x cube. X cube means a cube tan cube theta. A cube tan cube theta divided by a cube minus 3a into a square tan square theta. Right? ಬರೀ ಫಾರ್ಮಲ್ಲಿ ಜಸ್ಟ್ ಅದನ್ನ ಫಸ್ಟ್ ಡಿವೈಡ್ ಮಾಡ್ಕೊಂಡು ನಾನು ಸಿಂಪಲ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಕ್ ಹೋಗಲ್ಲ. ಜಸ್ಟ್ ಎಕ್ಸ್ ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ನೆಕ್ಸ್ಟ್ ಅದೇ ಕಾನ್ಸೆಪ್ಟ್ ಬರುತ್ತೆ. ಎ ಕ್ಯೂಬ್ ಕಾಮನ್ ತಗೊಂಡು ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ಕೊಂತೀನಿ, ನೋ ಇಶ್ಯೂಸ್. ರೈಟ್, ಎಕ್ಸ್ ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಏನ ಇನ್ಕ್ಲೂಡ್ ಮಾಡಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಬರ್ಕೊಂಬಿಡಿ. ಫಸ್ಟ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎ ಟ್ಯಾನ್ ಥೀಟಾ. ಸೊ ನಾವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಟರ್ಮ್ಸ್ ಈ ಫಾರ್ಮ್ಗೆ ರಿಅರೇಂಜ್ ಆಗುತ್ತೆ. again which is equal to tan inverse of, ಸೊ ಆಗ್ಲೇ ಬರ್ಕೊಂಡಿದ್ದ ನಾನು a ಕ್ಯೂಬ್ ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ದ. ಸೊ ಈಗ ನಮ್ಗೆ ಈಸಿ ಅನ್ಸುತ್ತೆ, ಜಸ್ಟ್ a ಕ್ಯೂಬ್ ಅನ್ನ ಕಾಮನ್ ತಗೊಳ್ಳಿ ಅಷ್ಟೇ. ಓಕೆ, ಸೊ ಆಗ್ಲೇ ನಾನು ಡಿವೈಡ್ ಮಾಡ್ತಾ ಇದ್ದೆ. ಸೊ a ಕ್ಯೂಬ್ ಕಾಮನ್ ತಗೊಂಡು ನ್ಯೂಮರೇಟರ್ ಮತ್ತೆ ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ a ಕ್ಯೂಬ್ ಕಾಮನ್ ತಗೊಂಡು ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿದ್ರು ಅದೇ ಮೀನಿಂಗ್ ಬರುತ್ತೆ. ಜಸ್ಟ್ ದಟ್ ಮೀನ್ಸ್ ನ್ಯೂಮರೇಟರ್ ಮತ್ತೆ ಡಿನಾಮಿನೇಟರ್ ನ a ಕ್ಯೂಬ್ ಇಂದ ಡಿವೈಡ್ ಮಾಡಿ. ಸೊ ಹಿಯರ್ ಆಲ್ಸೋ ಓಕೆ, ಸೊ ಜಸ್ಟ್ ನಾನು ಫಸ್ಟೇ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಬರ್ಕೊಂಡಿರೋದ್ರಿಂದ a ಕ್ಯೂಬ್ ಆಲ್ರೆಡಿ ಬಂದಿದೆ. ಸೊ a ಕ್ಯೂಬ್ ಕಾಮನ್ ತಗೊಳ್ತೀನಿ. a ಕ್ಯೂಬ್ ಕಾಮನ್ ತಗೊಂಡ್ರೆ ಸೊ ಹಿಯರ್ ಯು ವಿಲ್ ಗೆಟ್ 3 tan theta. a ಕ್ಯೂಬ್ ಕಾಮನ್ ತಗೊಂಡು 3 tan theta ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಮೈನಸ್ a ಕ್ಯೂಬ್ tan ಕ್ಯೂಬ್ theta. a ಕ್ಯೂಬ್ ಕಾಮನ್ ತಗೊಂಡಿದೀವಿ, tan ಕ್ಯೂಬ್ theta ಡಿವೈಡ್ ಬೈ ಡಿನಾಮಿನೇಟರ್ ಆಲ್ಸೋ. ಇಲ್ಲಿ ಒನ್ ಫಾರ್ಮ್ ಆಗಬೇಕು ಅಂತ ಹೇಳಿದಲ್ಲ, ಜಸ್ಟ್ ಈಗ a ಕ್ಯೂಬ್ ಆಸ್ ಕಾಮನ್, a ಕ್ಯೂಬ್ ಅನ್ನ ಕಾಮನ್ ತಗೊಳ್ಳಿ. ಸೊ ಯು ವಿಲ್ ಗೆಟ್ 1 ಮೈನಸ್ 3a into a square tan square theta. a ಕ್ಯೂಬ್ ಕಾಮನ್ ತಗೊಂಡಿದೀವಿ ಅಂದ್ರೆ 3 tan square theta ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ರೈಟ್, ಸೊ ನ್ಯೂಮರೇಟರ್ ಮತ್ತೆ ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ a ಕ್ಯೂಬ್ ಅನ್ನ ಕಾಮನ್ ತಗೊಂಡಿದ್ದೀವಿ. ಅಗೈನ್ tan inverse of a ಕ್ಯೂಬ್ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿದ್ರೆ 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Tan inverse of 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Now this is of the form 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. We should know the formula. Formula ಗೊತ್ತಿರಬೇಕು. So tan 3 theta formula. Okay. So first time use ಮಾಡ್ತಾ ಇದೀನಿ tan 3 theta formula. So tan 3 theta formula 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. So which is equal to tan inverse of tan 3 theta. Tan inverse of tan 3 theta. Tan inverse of tan 3 theta, which is equal to 3 theta. Tan inverse of tan 3 theta, so that can be written as 3 theta. So again, which is equal to 3 theta. So theta means tan inverse of x by a. Theta means tan inverse of x by a. So this is the simplest form of the given function. Again, ಕೊಟ್ಟಿದ್ದಾರೆ function. A function in a simplest form 3 tan inverse of x by a. Okay. So ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರ್ಕೊಳ್ಳಿ. ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೆದ್ರು ಅಂದ್ರೆ ಅಥವಾ ನೀವು ವೆರಿ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಅನ್ನು a ಕ್ಯೂಬ್ ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ಸೊ ಈ ಫಾರ್ಮ್ ಗೆ ಬರುತ್ತೆ. a ಕ್ಯೂಬ್ ಇಂದ ಡಿವೈಡ್ ಮಾಡಿ ಸೊ ದೆನ್ x is equal to a tan theta ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ಕೊಂಡು ಇದೇ ಫಾರ್ಮ್ ಗೆ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಬಟ್ ಯೂಶುವಲ್ ಆಗಿ ನಾವು ಪ್ರೀವಿಯಸ್ ಸಮ್ಸ್ ಎಲ್ಲ ಫಸ್ಟ್ ಇದನ್ನು ಡಿಫೈನ್ ಮಾಡಿದ್ದೀವಿ, ಹಾಗಾಗಿ ಇದೇ ಫಾರ್ಮ್ ಅಲ್ಲೇ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದೀನಿ ಅಷ್ಟೇ. ರೈಟ್. ಸೊ ರೈಟ್ ಡೌನ್ ದಿಸ್ ಥಿಂಗ್. ಇಷ್ಟನ್ನು ಬರ್ಕೊಳ್ಳಿ ಹಾಗೆ. Okay. So next one, next ಕೆಲವು equations ಕೂಡ discuss ಮಾಡ್ತೀವಿ. Okay. So equation means we have to solve. So that means we have to find the value or values of x. Okay. So the question be like this. Solve tan inverse 2x plus tan inverse of 3x is equal to pi by 4. Solve tan inverse of 2x plus tan inverse of 3x is equal to pi by 4. So here you have to find the value of x. X value na calculate ಮಾಡಬೇಕು. Solve ಅಂದ್ರೆ understood. You have to find the value of unknown, that is here x. Tan inverse 2x plus tan inverse 3x is equal to pi by 4. So simple ಆಗಿರೋಂತ problem. First I will write the given equation. Given equation is tan inverse 2x plus tan inverse 3x is equal to pi by 4. So this is the given equation. Again, this can be written as tan inverse of. So this is the form tan inverse x plus tan inverse y. Tan inverse x plus tan inverse y form alide tan inverse of x plus y divided by 1 minus xy ಅಂತ ಬರ್ಕೊಳ್ತೀವಿ. Okay. So tan inverse x plus tan inverse y, which is equal to tan inverse of x plus y divided by 1 minus xy. That is 2x plus 3x divided by 1 minus 2x into 3x is equal to pi by 4. Right? So tan inverse x plus tan inverse y, which is equal to tan inverse of x plus y divided by 1 minus x into y is equal to pi by 4. Again, simplify this one. 2x plus 3x, 5x by 1 minus, multiply these two factors, 6x square. 6x square, which is equal to tan inverse na kade shift ಮಾಡಿದ್ರೆ you will get tan pi by 4. Tan of pi by 4 ಆಗುತ್ತೆ. ಇನ್ವರ್ಸ್ ಫಂಕ್ಷನ್ ಅನ್ನು ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕಲ್ ಫಂಕ್ಷನ್ ಗೆ ಚೇಂಜ್ ಮಾಡಿದೀವಿ. ರೈಟ್. ಅಗೈನ್ 5x divided by 1 minus x square is equal to tan pi by 4 value. Tan pi by 4 value 1. So you will get 5x divided by 1 minus 6x square is equal to 1. Again 5x is equal to 1 minus 6x square. Right? 5x is equal to 1 minus 6x square. Just rearrange ಮಾಡಿ ಒಂದು ಕ್ವಾಡ್ರಾಟಿಕ್ ಈಕ್ವೇಶನ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಿ ಇದನ್ನು 6x square plus 5x minus 1 is equal to 0. ಜಸ್ಟ್ ರಿಅರೇಂಜ್ ಮಾಡಿ, ಅಂದ್ರೆ ರಿಅರೇಂಜ್ ಮೀನ್ಸ್ ಜಸ್ಟ್ ಇವೆರಡು ಟರ್ಮ್ಸ್ ನ ಲೆಫ್ಟ್ ಸೈಡ್ ಶಿಫ್ಟ್ ಮಾಡಿದೀನಿ ಅಷ್ಟೇ. ರಿಅರೇಂಜ್ ಮಾಡಿ ಒಂದು ಕ್ವಾಡ್ರಾಟಿಕ್ ಈಕ್ವೇಶನ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ರಿಅರೇಂಜ್ ಮಾಡ್ತೀನಿ. ಅಗೇನ್ ಪ್ರಾಡಕ್ಟ್ ಇಸ್ -6, ಸಮ್ ಮಸ್ಟ್ ಬಿ 5, ಸಮ್ 5 ಆಗಿರಬೇಕು, ಪ್ರಾಡಕ್ಟ್ -6 ಆಗಿರಬೇಕು. ಸೊ ಫ್ಯಾಕ್ಟರ್ಸ್ can we write 5 ones are, sorry 6 is there, 6 ones are, minus sign is there, -1 here plus 5 is there. 6 and -1 are the factors. 6 ಮತ್ತೆ -1 factors ಆಗಿರುತ್ತೆ. ಹಾಗಾಗಿ 6x square plus 6x minus x minus 1 is equal to 0. 5x ಅನ್ನು 6x minus x ಅಂತ ಬರ್ಕೊಳ್ತೀವಿ. Again in first two terms we can take 6x as common. 6x ಅನ್ನ ಕಾಮನ್ ಆಗಿ ತಗೊಬಹುದು. ರಿಮೈನಿಂಗ್ ಟರ್ಮ್ x ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಸೆಕೆಂಡ್ ಟರ್ಮ್ ಅಲ್ಲಿ 1 ಉಳ್ಕೊಳ್ಳುತ್ತೆ. And next two terms ಅಲ್ಲಿ ಮೈನಸ್ ಸೈನ್ ಅನ್ನ ಕಾಮನ್ ತಗೋ. x plus 1 into 0. Right? So again take x plus 1 as common. x plus 1 ಅನ್ನ ಕಾಮನ್ ಆಗಿ ತಗೊಳ್ಳಿ. You will get 6x minus 1 is equal to 0. Okay, so yeah, either x is equal to -1 or x is equal to 1 by 6. Individual factors ಅನ್ನು 0 ಗೆ ಇಕ್ವೇಟ್ ಮಾಡಿದ್ರೆ x is equal to -1 or x is equal to 1 by 6 ಬರುತ್ತೆ. Here we have two values. Equation observe ಮಾಡಿ. Tan inverse 2x plus tan inverse of 3x is equal to pi by 4 is there. If you substitute -1 in place of x, x ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ -1 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ you will get tan inverse of -2 plus tan inverse of -3. Right? Tan inverse of -2, tan inverse of -3, two negative quantities ನ ಸಮ್ ಮಾಡಿದ್ರೆ ಪಾಸಿಟಿವ್ ಕ್ವಾಂಟಿಟಿ ಫಾರ್ಮ್ ಆಗಲ್ಲ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? x ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ -1 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ ಇರೋಂತ ಎರಡು ಟರ್ಮ್ಸ್ ನೆಗೆಟಿವ್ ಕ್ವಾಂಟಿಟೀಸ್ ಆಗುತ್ತೆ. ಟೂ ನೆಗೆಟಿವ್ ಕ್ವಾಂಟಿಟೀಸ್ ನ ಸಮ್ ಮಾಡಿದ್ರೆ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ 5/4 ಒಂದು ಪಾಸಿಟಿವ್ ಕ್ವಾಂಟಿಟಿ ಇದೆ. ಪಾಸಿಟಿವ್ ಕ್ವಾಂಟಿಟಿ ಫಾರ್ಮ್ ಆಗಲ್ಲ. ಹಾಗಾಗಿ ಎಕ್ಸ್ ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ -1 ಅಂತ ತಗೊಂಡಿದೀವಿ. ಸೊ ಇದು ಸೊಲ್ಯೂಷನ್ ಆಗಲ್ಲ, ಇಟ್ ಇಸ್ ರಿಜೆಕ್ಟೆಡ್. ಅವ್ರ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಏನು ಬೇಕಿಲ್ಲ, ಐ ರೈಟ್ ರಿಜೆಕ್ಟೆಡ್ ಆ ಸೊಲ್ಯೂಷನ್. ಸೊ ದಟ್ ಮೀನ್ಸ್ ಅದು ಸೊಲ್ಯೂಷನ್ ಆಗಿರಲ್ಲ. ಎಕ್ಸ್ ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ -1 ಇದೆ. ಸೊ ಹಾಗಾದ್ರೆ x ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ 1/6 ತಗೊಂಡ್ರೆ, x ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ 1/6 ತಗೊಂಡ್ರೆ ಫಸ್ಟ್ ಟರ್ಮ್ 1/3 ಆಗುತ್ತೆ, ಸೆಕೆಂಡ್ ಟರ್ಮ್ 1/2 ಆಗುತ್ತೆ. ಸೊ tan inverse of 1/3 tan inverse of 1/2 is equal to pi/4. Equation satisfy ಆಗುತ್ತೆ. So therefore x is equal to 1/6 is the solution. So this is the only solution. Okay, so x is equal to 1/6, not -1. ಇಕ್ವೇಶನ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ -1 ಬಂದಿದೆ, ಬಟ್ ಈಕ್ವೇಶನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡ್ತಾ ಇಲ್ಲ ಆ ವ್ಯಾಲ್ಯೂ. ಹಾಗಾಗಿ ಅದನ್ನ ನಾವು ಸೊಲ್ಯೂಷನ್ ಅಂತ ಟ್ರೀಟ್ ಮಾಡಲ್ಲ. ಎಕ್ಸ್ ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ 1/6 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಈಕ್ವೇಶನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಅದನ್ನ ನಾವು ಸೊಲ್ಯೂಷನ್ ಅಂತ ಟ್ರೀಟ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ರೈಟ್ ಡೌನ್ ದಿಸ್ ಥಿಂಗ್. ಸೊ ಈಸಿ ಆಗಿರೋಂಥ ಪ್ರಾಬ್ಲಮ್. ಜಸ್ಟ್ tan inverse x plus tan inverse y ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ತಾ ಹೋಗಿದ್ದೀವಿ. ಸೊ ರೈಟ್ ಡೌನ್ ದಿಸ್ ಥಿಂಗ್. Okay, so next sum. So condition ನೋಡಿ equation ನೋಡಿ ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದೆ tan inverse of x minus 1 by x minus 2 plus tan inverse of x plus 1 divided by x plus 2 is equal to pi by 4. ಇವೆರಡು ಇನ್ವರ್ಸ್ ಫಂಕ್ಷನ್ ಸಮ್ ಮಾಡಿದ್ರೆ pi by 4 ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ. ಸೊ ದೆನ್ ಫೈಂಡ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ x. ವ್ಯಾಲ್ಯೂ ಆಫ್ x ಅನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಆಸ್ ಯೂಶುವಲ್ ಮೆಥಡ್ ಆಫ್ ಸಾಲ್ವಿಂಗ್ ಅಲ್ಲಿ ಏನು ಚೇಂಜಸ್ ಇಲ್ಲ, ಅದನ್ನ ರಿಪೀಟ್ ಮಾಡ್ತೀನಿ. ಬಟ್ ಇಲ್ಲಿ ಟರ್ಮ್ಸ್ ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಪ್ರೀವಿಯಸ್ ನಮ್ಮಲ್ಲಿ 2x 3x ಈಸಿ ಆಗಿತ್ತು, ಇದು ಫ್ರಾಕ್ಷನ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದೆ. ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಸ್ವಲ್ಪ ಲೆಂತಿ ಆಗುತ್ತೆ ಅಷ್ಟೇ, ಬಟ್ ಮೆಥಡ್ ಆಫ್ ಸಾಲ್ವಿಂಗ್ ಅಲ್ಲಿ ಏನು ಚೇಂಜಸ್ ಇಲ್ಲ. ರೈಟ್. ಸೊ ಫಸ್ಟ್ ಗಿವನ್ ಈಕ್ವೇಶನ್ ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಗಿವನ್ ಈಕ್ವೇಶನ್ ಬರ್ಕೊಳ್ತೀನಿ. ಸೊ ಗಿವನ್ ಈಕ್ವೇಶನ್ tan ಇನ್ವರ್ಸ್ ಆಫ್ x minus 1 by x minus 2 plus tan inverse of x plus 1 divided by x plus 2 is equal to pi by 4. Right? What's the given equation? Tan inverse x plus tan inverse y form. Tan inverse of x plus y, that is x minus 1 by x minus 2 plus x plus 1 by x plus 2 whole divided by 1 minus x minus 1 into x minus 2 into x plus 1 by x plus 2. Okay, very well formally. So tan inverse x plus tan inverse y, so that can be done as tan inverse of x plus y divided by 1 minus xy. Terms ಜಾಸ್ತಿ ಇದೆ, ಬಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಅದನ್ನೇ, ಕಾನ್ಸೆಪ್ಟ್ ನಾನು ಚೇಂಜ್ ಮಾಡಿಲ್ಲ, ಅದೇ ಫಾರ್ಮ್ ನ ಯೂಸ್ ಮಾಡಿ. ಇಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು pi by 4. ಅಗೈನ್ ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ. ಸೊ ಇದರ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ x minus 2 x plus 2 LCM ತಗೊಂಡ್ರೆ x plus 2 x minus 1 ಮಲ್ಟಿಪ್ಲೈ ಆಗುತ್ತೆ, x minus 2 x plus 1 ಮಲ್ಟಿಪ್ಲೈ ಆಗುತ್ತೆ. ರೈಟ್. x minus 1 into x plus 2 plus x plus 1 into x minus 2 whole divided by. So denominator ನಾನು ಬರೆಯೋದಕ್ಕೆ ಹೋಗಲ್ಲ, ಬಿಕಾಸ್ ಡಿನಾಮಿನೇಟರ್ LCM ತಗೊಂಡಾಗ ಸೇಮ್ ಟರ್ಮ್ ಇರುತ್ತೆ, ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಸೊ ಡಿನಾಮಿನೇಟರ್ ಅಷ್ಟೇ x minus 2 x plus 2 ನ LCM ತಗೊಳ್ಳಿ. x minus 2 into x plus 2 minus x minus 1 into x plus 1 which is equal to tan pi by 4. Right? ಬರೀಬಹುದಾ? ಸೊ ನ್ಯೂಮರೇಟರ್ ಮತ್ತೆ ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ತಗೊಂಡಿರೋಂತ LCMs ಕ್ಯಾನ್ಸಲ್ ಆಗಿದೆ, ನ್ಯೂಮರೇಟರ್ಸ್ ಅನ್ನು ಮಾತ್ರ ಬರ್ಕೊಂಡಿದ್ದೀನಿ. x minus 1 into x plus 2 x plus 1 into x minus 2, ಡಿನಾಮಿನೇಟರ್ x minus 2 into x plus 2 minus x minus 1 into x plus 1. ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ. ಫರ್ದರ್ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್, if you multiply by x numerator, you will get x square plus 2x. x ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ x square plus 2x ಆಗುತ್ತೆ. minus 1 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ minus x minus 2 ಪ್ಲಸ್ x ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ, x ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ x square minus 2x, 1 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ x minus 2. ಸೊ ಅದನ್ನು ನೋಡ್ಕೊಂಡು ನೀವೇ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಳ್ಳಿ. ಯೂಶುವಲ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಅಷ್ಟೇ. ಫಸ್ಟ್ x ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ, ನೆಕ್ಸ್ಟ್ minus 1 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ. ಸೊ ಫಸ್ಟ್ x ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ, ಆಮೇಲೆ 1 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ. ಡಿನಾಮಿನೇಟರ್ ಸೊ ಇವನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು, ಬಟ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫಾರ್ಮ್ ಅಲ್ಲೇ ಇದೆ. x minus 2 into x plus 2, that is a minus b into a plus b, a square minus b square ಅಂತ ಬರೀಬಹುದು. That is x square minus 2 square, 2 square means 4, x square minus 4 minus x minus 1 into x plus 1, x minus 1 into x plus 1 can be done as x square minus 1. So this is also a minus b into a plus b, a square minus b square, x square minus 1, which is equal to, right hand side tan pi by 4 is there, tan pi by 4 value 1, tan 45 degree. Right. So next it's a simplification. ಇದರ simplification ಏನಾಗುತ್ತೆ, ನ್ಯೂಮರೇಟರ್ x square plus x square 2x square plus 2x minus 2x cancel ಆಗುತ್ತೆ, plus 2x minus 2x cancel ಮಾಡ್ತೀವಿ. Again minus x ಪ್ಲಸ್ ಎಕ್ಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಮೈನಸ್ ಎಕ್ಸ್ ಪ್ಲಸ್ ಎಕ್ಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, minus 2 minus 2 for the same side, minus 2 minus 2 means minus 4. Okay, so complete numerator simplification 2x square minus 4 ಆಗುತ್ತೆ, 2x square minus 4. Denominator x square cancel ಆಗುತ್ತೆ, minus 4, so here minus into minus plus 1, minus 4 plus 1 means minus 3 is equal to 1. Denominator ಅಲ್ಲಿ x square cancel ಆಗುತ್ತೆ, minus 4 plus 1 ಅನ್ನ minus 3 ಅಂತ ಬರೀಬಹುದು. Right? So again mathematically ಆ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. 2x square minus 4 is equal to minus 3. Okay, 2x square minus 4 is equal to ಈ minus 3 ನ right hand side cross multiply ಮಾಡಿ. Again which is equal to 2x square is equal to 1. minus 4 ಅನ್ನ right hand side ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ 4 minus 3 ಆಗುತ್ತೆ, 4 minus 3 means 1. 2x square is equal to 1. 2x square is equal to 1 ಆದ್ರೆ x square is equal to 1 by 2. x square is equal to 1 by 2. x square is equal to 1 by 2 ಆದ್ರೆ x is equal to plus or minus 1 by root 2. So these are the values of x. Okay, x is equal to plus or minus 1 by root 2. Previous sum ಏನಿದೆಯೋ ಅದೇ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡಿರೋಂತ ಇನ್ನೊಂದು ಸಮ್ ಅಷ್ಟೇನೆ. ಬಟ್ ಪ್ರೀವಿಯಸ್ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ 2x 3x ಈಸಿ ಆಗಿರೋಂಥ ಟರ್ಮ್ಸ್ ಇಲ್ಲಿ ಫ್ರಾಕ್ಷನ್ಸ್ ಇದೆ, ಫ್ರಾಕ್ಷನ್ಸ್ ಅನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಂಡಿದೀವಿ ಅಷ್ಟೇ. ಓಕೆ, ಸೊ ಇದೇನಿದೆ ಆಸ್ ಇಟ್ ಇಸ್ ಆಗಿ ಬರ್ಕೊಳ್ಳಿ. ಮೆಥಡ್ ಆಫ್ ಸಾಲ್ವಿಂಗ್ ಏನು ಚೇಂಜಸ್ ಇಲ್ಲ. ಸೊ ರೈಟ್ ಆನ್ ದಿಸ್. Okay, so last problem. Solve tan inverse of 1 minus x divided by 1 plus x is equal to 1 by 2 tan inverse x. Okay, next problem. Solve tan inverse of 1 minus x divided by 1 plus x is equal to 1 by 2 tan inverse x. Sir, first write down the given equation. So given equation is tan inverse of 1 minus x divided by 1 plus x is equal to 1 by 2 tan inverse x. Given equation, tan inverse of 1 minus x divided by 1 plus x is equal to 1 by 2 tan inverse x. So this is the given equation. Next, in left hand side, we can simplify like this. So क्या tan inverse x, sorry, tan inverse of x minus y divided by 1 plus xy. That can be done as tan inverse x minus tan inverse y, right? tan inverse of x minus y divided by 1 plus xy ನ tan inverse x minus tan inverse y ಅಂತ ಬರೀಬಹುದು. ಆ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಈ ಫಂಕ್ಷನ್ ಅನ್ನ ಕಂಪೇರ್ ಮಾಡಿ. x ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ 1 ಇದೆ, y ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ x ಇದೆ ಅಂತ ಹೇಳ್ತೀನಿ. ಈ ಫಾರ್ಮ್ ಕಂಪ್ಯಾರಿಸನ್ ತಗೊಂಡಾಗ in place of x here we have 1, in place of y we have x. So this can be done as tan inverse 1 minus tan inverse x. Tan inverse 1 minus tan inverse x ಅಂತ ಬರೀಬಹುದು. ಆ ಫಾರ್ಮ್ ಕಂಪ್ಯಾರಿಸನ್ ತಗೊಳ್ಳಿ. So tan inverse 1 minus tan inverse x again, which is equal to 1 by 2 tan inverse x. 1 by 2 tan inverse x again, which is equal to tan inverse 1 is pi by 4, which is equal to tan inverse x and opposite side shift ಮಾಡಿದ್ರೆ plus tan inverse x ಆಗುತ್ತೆ. tan inverse x plus 1 by 2 tan inverse x. tan inverse x plus 1 by 2 tan inverse x. tan inverse x plus 1 by 2 tan inverse x ಇವೆರಡನ್ನು ಸಮ್ ಮಾಡಿದ್ರೆ so that means 1 plus 1 by 2 ಆಗುತ್ತೆ. 1 plus 1 by 2 means 3 by 2. 3 by 2 tan inverse x is equal to pi by 4. ಬರೆಯೋದಾ ಈ ಫಾರ್ಮಲ್ಲಿ? ಇವೆರಡನ್ನು ಸಮ್ ಮಾಡಿ, ಇವೆರಡು ಸಮ್ ಮಾಡಿದ್ರೆ 1 plus 1 by 2 ಆಗುತ್ತೆ. You will get 3 by 2. 3 by 2 tan inverse x is equal to pi by 4. Next 2 1s 2 2s cancel ಆಗುತ್ತೆ. So tan inverse x is equal to tan inverse x is equal to pi by 6. Pi by 6. 3 cross multiply ಮಾಡಿ 2 3s 6 ಆಗುತ್ತೆ. tan inverse x is equal to pi by 6. Again x is equal to tan of pi by 6. X is equal to tan of pi by 6. Pi by 6 means 30 degree. So tan 30 degree value ಬಂದು 1 by root 3. X is equal to 1 by root 3. Okay. So this is the solution. Simple ಆಗಿದೆ. ಇಲ್ಲಿ ಯಾವುದೇ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡ್ತಾ ಇಲ್ಲ, ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಕೊಂತಾ ಇದೀನಿ ಅಷ್ಟೇ ಟರ್ಮ್ಸ್ ಅನ್ನ. tan inverse of 1 minus x divided by 1 plus x ಅನ್ನ tan inverse 1 minus tan inverse x. ಪ್ರೀವಿಯಸ್ ಟು ಸಮ್ಸ್ ಯಾವ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದ್ದು ಅಂದ್ರೆ ಈ ಎರಡು ಫಾರ್ಮ್ 2 ಟರ್ಮ್ಸ್ ಇದ್ದು ಈ ಫಾರ್ಮುಲಾ ಈ ತರ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿದೀವಿ. ಬಟ್ ಇಲ್ಲಿ ಟರ್ಮ್ಸ್ ನ ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಕೊಂಡು ಆಡ್ ಮಾಡಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ತೀವಿ. ಸೊ ವ್ಯಾಲ್ಯೂ ಆಫ್ x you will get 1 by root 3. 1 by root 3 ಬರುತ್ತೆ. Okay. So write down this. Okay. So next problem. Sin inverse 1 minus x minus 2 sin inverse x is equal to pi by 2. Okay. So this is the last sum. So ಈ ಸಮ್ಗೆ ಈ ಚಾಪ್ಟರ್ ನ ಎಂಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸಾಲ್ವ್ sin inverse 1 minus x minus 2 sin inverse x is equal to pi by 2. Okay. In terms of sin alliದೆ. So previous equations 3 equations in terms of tan alaitu, but ee particular problem in terms of sin alide. So simplify ಮಾಡ್ತಾ ಹೋಗೋಣ. First I will write the given equation. Given equation is sin inverse 1 minus x minus 2 sin inverse x is equal to pi by 2. So given equation sin inverse 1 minus x minus 2 sin inverse x is equal to pi by 2. So this is the given equation. Next, shift sin inverse of 1 minus x to right hand side. Right hand side shift ಮಾಡ್ಕೊಳ್ಳಿ. 2 sin inverse x is equal to pi by 2 minus sin inverse 1 minus x. ಶಿಫ್ಟ್ ಮಾಡಿದ್ವಿ. ವೈ? ಸೊ ಏನಕ್ಕೆ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ ನಾವು ಆ ಟರ್ಮ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಶಿಫ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಸೆಕೆಂಡ್ ಟರ್ಮ್ ಶಿಫ್ಟ್ ಮಾಡ್ತಾ ಇಲ್ಲ. ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ ಈ ಟರ್ಮ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಏನ್ ಶಿಫ್ಟ್ ಮಾಡಬೇಕು. ಸೊ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಇದನ್ನ ಪ್ರಾಪರ್ಟಿ ರಿಲೇಟ್ ಮಾಡ್ಕೊಂತೀವಿ. ಸೊ ಪ್ರಾಪರ್ಟಿ ರಿಲೇಷನ್ ಸೈನ್ ಇನ್ವರ್ಸ್ ಎಕ್ಸ್ ಪ್ಲಸ್ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು π/2. ವಿ ಹ್ಯಾವ್ ದಿ ಪ್ರಾಪರ್ಟಿ ಲೈಕ್ ದಿಸ್. ಪ್ರಾಪರ್ಟೀಸ್ ದಲ್ಲಿ ಈ ತರದ ಇನ್ವರ್ಸ್ ಫಂಕ್ಷನ್ ಅಲ್ಲಿ ಒಂದು ಪ್ರಾಪರ್ಟಿ ಇದೆ. ಸೈನ್ ಇನ್ವರ್ಸ್ ಎಕ್ಸ್ ಪ್ಲಸ್ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಎಕ್ಸ್ ಅನ್ನ π/2 ಅಂತ ಬರೀಬಹುದು. ಸೈನ್ ಇನ್ವರ್ಸ್ ಎಕ್ಸ್ ಪ್ಲಸ್ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು π/2 ಆದ್ರೆ π/2 ಮೈನಸ್ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಎಕ್ಸ್ ಕ್ಯಾನ್ ಬಿ ರಿಟನ್ ಆಸ್ ಸೈನ್ ಇನ್ವರ್ಸ್ ಎಕ್ಸ್ ಆರ್ π/2 ಮೈನಸ್ ಸೈನ್ ಇನ್ವರ್ಸ್ ಎಕ್ಸ್ ಕ್ಯಾನ್ ಬಿ ರಿಟನ್ ಆಸ್ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಎಕ್ಸ್. ರೈಟ್? ಸೊ ದಟ್ಸ್ ವೈ ಫಸ್ಟ್ ಟರ್ಮ್ ಅನ್ನ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಶಿಫ್ಟ್ ಮಾಡಿದ್ದೀನಿ. ಈಗ π/2 ಮೈನಸ್ ಸೈನ್ ಇನ್ವರ್ಸ್ ಆಫ್ 1 ಮೈನಸ್ ಎಕ್ಸ್ ಆ ಪ್ರಾಪರ್ಟಿ ಯೂಸ್ ಮಾಡಿದ್ರೆ ವಿ ಕ್ಯಾನ್ ರೈಟ್ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಆಫ್ 1 ಮೈನಸ್ ಎಕ್ಸ್. π/2 ಮೈನಸ್ ಸೈನ್ ಇನ್ವರ್ಸ್ ಆಫ್ 1 ಮೈನಸ್ ಎಕ್ಸ್ ಅನ್ನ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಆಫ್ 1 ಮೈನಸ್ ಎಕ್ಸ್ ಅಂತ ಬರೀಬಹುದು. In left hand side we have -2 sin inverse x. Again inverse trigonometric function ana trigonometric function change ಮಾಡ್ತಾನೆ. You will get cos of 2 sin inverse x is equal to 1 minus x. Okay, I will write minus sign. Cos of -2 sin inverse x is equal to 1 minus x. ಇವಾಗ ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಜಸ್ಟ್ ಈ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಏನಿದೆ ಕಾಸ್ ಇನ್ವರ್ಸ್ ನ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಶಿಫ್ಟ್ ಮಾಡ್ಕೊಂಡಿದೀವಿ. ಕಾಸ್ ಆಫ್ -2 sin inverse x is equal to 1 minus x. Cos of minus theta, here minus sign is there. Cos of minus theta is cos theta, so this can be done as cos of 2 sin inverse x is equal to 1 minus x. ಈ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಸೈನ್ ಅನ್ನು ಅವಾಯ್ಡ್ ಮಾಡಿದೀವಿ. Cos of minus theta form ಇದೆ. You can write cos theta. Cos of 2 sin inverse x. Again we have the formula cos 2 theta. Cos 2 theta can be done as 1 minus 2 sin square theta in terms of sin. In terms of cos ಬರಿಬೇಕಾದ್ರೆ 2 cos square theta minus 1 ಅಂತ ಬರ್ಕೊಳ್ತೀವಿ. In terms of sin cos 2 theta can be done as 1 minus 2 sin square theta. 1 minus 2 sin square theta ಅಂತ ಬರ್ಕೊಳ್ತೀವಿ. ಸೊ ಹಾಗಾದ್ರೆ ಪ್ರಾಪರ್ಟಿ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಸರಿ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿದ್ರೆ 1 minus 2 sin square theta. In place of theta we have sin inverse x. Okay, cos 2 theta. Theta ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ sin inverse x ಇದೆ. ಆ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿ cos 2 theta 1 minus 2 sin square theta. So that means 1 minus 2 sin square theta. In place of theta we have sin inverse x. 1 minus 2 sin square sin inverse x is equal to 1 minus x. ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೀಬಹುದು. So now 1 minus 2 sin of sin inverse x. Sin of sin inverse x can be written as x ಪ್ರಾಪರ್ಟಿ ಯೂಸ್ ಮಾಡ್ಕೊಂತೀವಿ. sin of sin inverse x ಅನ್ನ x ಅಂತ ಬರ್ಕೊಳ್ತೀನಿ. ಸ್ಕ್ವೇರ್ ಇರೋದ್ರಿಂದ x ಸ್ಕ್ವೇರ್ ಆಗುತ್ತೆ. x square is equal to 1 minus x. Okay, 1 minus 2x square is equal to 1 minus x. Again 1 cancel ಮಾಡಿ minus 2x square or 2x square is equal to x. Right? So 2x square is equal to x. 2x square is equal to x means x is equal to 0 or x is equal to 1/2. So that means you can take like this. ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬೇಕಾದ್ರೂ ತಗೊಬಹುದು. x square minus x is equal to 0. x ಕಾಮನ್ ತಗೊಂಡ್ರೆ 2x minus 1 is equal to 0. x is equal to 0 or x is equal to 1/2. It's quadratic equation. We have two values. x ನ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಬೇಡಿ. ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ 0 ಗೆ ಈಕ್ವೇಟ್ ಮಾಡ್ಕೊಬೇಕಾಗುತ್ತೆ. x is equal to 0 ಅಂತ ಒಂದು ವ್ಯಾಲ್ಯೂ. ಹಾಗಾಗಿ ಇಲ್ಲ ಅಂದ್ರೆ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ ಇಂಡಿವಿಜುವಲ್ ಆಗಿ ಟೂ ವ್ಯಾಲ್ಯೂಸ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. x is equal to 0 or x is equal to 1/2. ಓಕೆ, x ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ 0 ಅಸೈನ್ ಮಾಡಿದ್ರೆ ಈಗ ಅಬ್ಸರ್ವ್ ಮಾಡಿ sin ಫಸ್ಟ್ ಟರ್ಮ್ sin ಇನ್ವರ್ಸ್ 1 ಆಗುತ್ತೆ. sin ಇನ್ವರ್ಸ್ 1 ಮೀನ್ಸ್ π/2. ಇಲ್ಲಿ ಎಕ್ಸ್ ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ 0 ಅಸೈನ್ ಮಾಡಿದ್ರೆ ಸೈನ್ ಇನ್ವರ್ಸ್ 0 0 ಕಂಡೀಷನ್ ಟ್ರೂ ಆಗುತ್ತೆ. ಎಕ್ಸ್ ಇಸ್ ಇಕ್ವಲ್ ಟು 0 ಇಸ್ ದಿ ಸೊಲ್ಯೂಷನ್. ನೆಕ್ಸ್ಟ್ ಎಕ್ಸ್ ಇಸ್ ಇಕ್ವಲ್ ಟು 1/2 ಇದೆ. ಎಕ್ಸ್ ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ 1/2 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ಸೊ ಈಕ್ವೇಶನ್ 1 ಮೈನಸ್ 1/2 ಮೀನ್ಸ್ ಇದು 1/2 1/2 ಮೀನ್ಸ್ ಇದು 30 ಡಿಗ್ರಿ ಆಗುತ್ತೆ. ಮೈನಸ್ ಸೊ ಇಲ್ಲಿ ಎಕ್ಸ್ ಇರೋ ಪ್ಲೇಸ್ ಅಲ್ಲಿ 1/2 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಸೊ 30 ಡಿಗ್ರಿ ಇಂಟು 2 60 ಡಿಗ್ರಿ ಆಗುತ್ತೆ, ವಿಚ್ ಇಸ್ ನಾಟ್ ಈಕ್ವಲ್ ಟು 90 ಡಿಗ್ರಿ. ಸೆಕೆಂಡ್ ವ್ಯಾಲ್ಯೂ ಏನಿದೆ ಆ ಸೆಕೆಂಡ್ ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ಈಕ್ವೇಶನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಲ್ಲ. ಸೊ ಈಕ್ವೇಶನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಲ್ಲ ಅಂದ್ರೆ ಇಟ್ಸ್ ನಾಟ್ ಸೊಲ್ಯೂಷನ್. ಜಸ್ಟ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಏನು ಕೊಡೋದಕ್ಕೆ ಹೋಗಲ್ಲ ನಾನು, ಜಸ್ಟ್ ಐ ರೈಟ್ ರಿಜೆಕ್ಟೆಡ್ ಅಂತ ಬರೀತೀನಿ. ಓಕೆ, ಎಕ್ಸ್ ಇಸ್ ಇಕ್ವಲ್ ಟು 0 ಇಸ್ ದಿ ಓನ್ಲಿ ಸೊಲ್ಯೂಷನ್. ಎಕ್ಸ್ ಇಸ್ ಇಕ್ವಲ್ ಟು 1/2 ಕ್ವಾಡ್ರಾಟಿಕ್ ಈಕ್ವೇಶನ್ ಫಾರ್ಮ್ ಆಗಿರೋದ್ರಿಂದ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ವ್ಯಾಲ್ಯೂ ಬಂದಿದೆ, ಬಟ್ ಆ ವ್ಯಾಲ್ಯೂ ಈಕ್ವೇಶನ್ ಅನ್ನ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡಲ್ಲ. ಹಾಗಾಗಿ ಇದನ್ನ ನಾವು ಸೊಲ್ಯೂಷನ್ ಅಂತ ಟ್ರೀಟ್ ಮಾಡಲ್ಲ. ಎಕ್ಸ್ ಇಸ್ ಇಕ್ವಲ್ ಟು 0 ಇಸ್ ದಿ ಓನ್ಲಿ ಸೊಲ್ಯೂಷನ್. ಓಕೆ, ಸೊ ಇದಿಷ್ಟು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. ಸೊ ಇಷ್ಟು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರೆ ಸೊ ಕಂಪ್ಲೀಟ್ ಚಾಪ್ಟರ್ ಇನ್ವರ್ಸ್ ಟ್ರಿಗ್ನಾಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ಸ್ ಅನ್ನೋ ಕಂಪ್ಲೀಟ್ ಚಾಪ್ಟರ್ ಇಲ್ಲಿಗೆ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಏನಾದರೂ ಡೌಟ್ಸ್ ಇದ್ರೆ ಕ್ವಶನ್ಸ್ ಅನ್ನ ವಾಟ್ಸಪ್ ಮಾಡಿ. ಸೊ ಇಲ್ಲಿಗೆ ಈ ಚಾಪ್ಟರ್ ಕಂಪ್ಲೀಟ್ ಆಯ್ತು. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.
ಗೊತ್ತಿಲ್ಲ ಇನ್ನೂ. ಹಲೋ, ಕೇಳಿಸ್ತಾ ಇದೆಯಲ್ಲ? someone please? Okay.
Okay, it was not listening, it seems. Okay, anyhow, it was not audible, I think. Anyhow, I'll explain once again. The four things that you learnt yesterday are electrostatic potential energy difference. It is nothing but the work done in bringing a charge that is plus q. The charge is plus q from one point to another point against the electric field, okay, with the help of an external force without accelerating. Okay, why it is not accelerating? The external force that we are applying and also the force due to this electric field, they are equal in magnitude. Okay, so it is moved with a constant speed without accelerating. So how much is the potential energy difference? It is UB minus UA is the work done in moving the charge from A to B, which is also equal to how much? Integration of force into displacement. Okay, so force is what? Electric force, electrostatic force. That external force is equal to minus Fe. Okay, so from A to B, if at all you move it from A to B, it's fine. This is the equation. Understood? This is what is potential energy difference. Once again, I'll tell you, it is the amount of work done in moving a point charge Q from one point to another point with the help of an external force without accelerating. Okay, you can also add on against electric field. Okay, now what is potential energy? Now we learned what is electric potential energy difference. Now potential energy. Okay, so you have what you have to do for potential energy. You have to place this point A at infinity. Okay, at infinity potential energy is 0. Then you get, if this is 0 at infinity, you get potential energy at one point, that is B. Okay, so that's how we get potential energy at one point in the electric field. So then how to define? It is the amount of potential energy at any point is the amount of work done, okay, in moving a charge, point charge Q, okay, from infinity to that point, any point, okay, B, without accelerating. Okay, same thing, but what? It is moved from infinity to this point B. Now, previous, it is moved from A to B. That's all. In both the cases, charge is plus Q. Okay. Now, if you want potential difference, electrostatic potential difference, then that's represented by VB minus VA. Okay, which is equal to how much? Okay, it's nothing but here you have to consider charge as 1 plus 1 coulomb. Okay, charge is unit positive charge. Okay, that's all. In every way, it is nothing but the definition of potential energy difference. Okay, so when charge is plus 1 coulomb and that charge is moved from one point to another point, what is the amount of work done? Okay, against the electric field. Okay, that work is done with the help of external force, you know, with a constant speed without accelerating. Okay, so that's why how will we get this VB minus VA equation, which is same as UB minus UA, potential energy difference, but moving unit positive charge. Okay, here we were moving a charge plus Q. Now, if you want to move, get the potential difference, you have to divide this by that Q. Okay, now this will be now transformed into what? Potential difference. This potential energy difference will become potential difference when you divide it by Q. Okay, so this is also work done, right? Work done. UB minus UA is also work done by Q. Okay. Now you are going to get a important relationship. Potential difference dV, here dV, potential difference, change in potential can also be written as dV is equal to this potential energy difference is work done. If it is small amount of work done, you can write dW by Q. Okay, or dW work done in moving the charge is also given by the charge into potential difference. Okay, this is another important equation you get from the same whatever you learned yesterday. Okay, fine. Next, potential at a point. If you want potential at a point in the electric field, potential at a point. How to get it? Again, you have to conveniently place this A to infinity. Okay, so A to infinity. Then, what is the amount of work done in moving unit positive charge, 1 coulomb, okay, from infinity to that point without accelerating is nothing but potential at a point. So, potential at a point is nothing but potential energy at a point by Q. Okay. So, this potential energy is nothing but the work done by Q. Okay. So, again you get, same kind of equation. Total amount of work done in moving the charge, okay, unit positive charge is, Q into V. Okay, this is how you get. So, total amount of work done in moving a charge is given by that charge into potential at that point. Okay, from the definition of potential. Okay, please go through once again. You read the textbook, all of you. Okay, so then only you can relate all the four together. Okay, you have to read and you must be able to differentiate these things clearly from one from another. Okay, then only you can say that you have understood. Okay, fine. Don't worry much about, if you have any confusion, little bit of it. When we use it again and again, it will sit properly in your mind. Okay, then you can clearly differentiate all these four. Okay, don't worry right now. Okay, now I am going to teach you the electric potential at a point due to an isolated charge. Okay, so electric potential at a point due to a charge or due to an isolated charge. Okay, so this is a derivation. Okay, it's a 5-mark derivation. We are getting a equation, okay, for the potential at one point, okay, due to an isolated charge. Say there is a charge configuration somewhere. Let the charge be plus Q. Okay, let the charge be plus Q at point say O, at one point O. Okay, this charge configuration, will be having some potential all around. Actually, it is producing some electric field all around. Okay, now in order to bring a charge near to this charge, so what is the work done? Okay, from infinity to that point, that is nothing but the potential. But the charge what you are bringing from infinity to this point is a unit positive charge. Okay, so that's why at any point P, we want to know what is the potential. What is the potential? V is how much? Okay, let this point be at a distance r from the isolated charge. Here is the plus Q charge. Okay, so at point P, we want to find out what is the potential. Okay, for this, what we have to do, we have to consider one charge, that is unit positive charge, 1 coulomb at A. We have to place what? 1 coulomb of charge at a point A, which is at a distance, let it be x from the source charge. Okay, this 1 coulomb is placed at what distance? At a distance x from the source charge. Okay, plus q. Okay, now let me consider another point B, which is at a distance dx. Is it clear what we are going to do? There is a positive charge plus q kept at O at a point close to it, I'd say maybe at a point P. We want to find out what is the potential due to this charge. Okay, and this point is at a distance r from this charge. Okay, in order to find out the potential at P, what I have to do? I have to consider unit positive charge. Okay, plus 1 coulomb at point A. Okay, fine. Now it is to be moved now. This one. So what is the force between these two charges? The electrostatic force between the charges. Which are they? Charges plus q and charges plus q and 1 coulomb is these are the two charges. What is that force? Fe is equal to 1 by 4 pi epsilon naught into q, this plus q into 1, q into 1. This is another q1, q2. See, q1, q2, q into 1 divided by what is the distance between these two charges, which is x square. Okay, this is, let this be equation 1. Okay, now this plus 1 coulomb should be moved from A to B through a small distance dx. Okay, now small amount of work is done. Let that small amount of work done be dw. Okay, so that I am going to write. Let dw be the small amount of work done, in moving what? In moving 1 coulomb, that is plus 1 coulomb from what? A to B. Okay, what is the distance? The distance is dx. So how much is that work done? dw is equal to force into displacement. Displacement is how much? Dx. Okay, this force is now electrostatic force, which is now I have to write, which is opposite to the applied force, which is opposite to the external force. So I will write it as minus Fe. Okay, minus Fe, because the electric field is this way, and the charge is moved in the opposite direction. Okay, so this applied force, external force, is opposite to electric force, so electrostatic force, so it is negative. Okay, fine. Now for this, from A to B to move, dw is the amount of work done. Now we want potential. See, potential at a point. Potential at a point, how to define? It is the amount of work done in moving unit positive charge from infinity to this point P. Infinity to this point. So we don't want this B. Instead, at point P. From there to this point P, we have to move it. So in moving so, what is the work done? That is nothing but electric potential, V. Okay. So what I'll do now? Say, dw is small amount of work done in moving through a small distance. Now, W, if you want, total amount of work done in moving the unit positive charge from infinity to this point P, I have to sum up all such dWs. Okay, summing up is what? It is the integration. I have to integrate this dW, okay, from between the integrals infinity and this point is at a distance r. Okay, then you get the total amount of work done. That work done itself is the potential, electric potential. Okay, so that's why I will write here total amount of work done, total amount of work done in moving +1 coulomb from infinity to P, point P is given by W is integration of, we have to sum up all such dW. The integrals are between infinity to this point is placed at a distance r. Here both you have to consider distances r, which is nothing but integration of dW. You already know how much, minus Fe into dx. Okay, so from infinity to r. Now you already know Fe, electrostatic force, minus Fe you have here 1 by 4 pi epsilon naught into q by x square is Fe into dx. Okay, between the integrals infinity and r. I hope it is clear. I just substituted everything here. Now we will integrate this one. We will integrate, and here minus 1 by 4 pi epsilon naught into q is a constant. I will take it out. What remains is 1 by x square. 1 by x square is x to the power minus 2. Okay, so W is equal to minus 1 by 4 pi epsilon naught or q by epsilon naught, 4 pi epsilon naught into integration of what? X to the power minus 2 with respect to x, between infinity to r. Now, integration of x to the power minus 2 with respect to x is x to the power minus 2 plus 1 divided by minus 2 plus 1. I hope you can remember that one. Q by 4 pi epsilon naught, integration of x to the power minus 2 is x to the power minus 2 plus 1 divided by same power minus 2 plus 1. Okay, now you have to substitute the integrals for this variable between infinity to r. Okay, yes. Now if you look at minus 2 plus 1 is minus 1. Okay, I will merge that minus 1 with this, or minus into minus is plus. Okay, then x to the power minus 2 plus 1 is x to the power minus 1. Okay, x to the power minus 1 is 1 by x. Okay, that I am going to write. W is equal to q by 4 pi epsilon naught into, again, x to the power minus 2 plus 1 is x to the power minus 1. So, x to the power minus 1 is 1 by x. Okay, 1 by x. Now, you have to put the variables once infinity and once r to this x, and you have to subtract them. Okay, which is equal to q by 4 pi epsilon naught into, in the place of this variable x, once you have to write r, 1 by r, minus, next you have to write infinity. These are the two integrals. We substituted that. 1 by infinity, 1 by 0 becomes 0, this term goes. Okay. So what you get is W is equal to 1 by 4 pi epsilon naught into this q is there, q by r. Okay, we got the work done, total amount of work done in moving unit positive charge from infinity to that point. That is defined to be what? Potential. Okay. Hence, electric potential V, electric potential or electrostatic potential V is equal to 1 by 4 pi epsilon naught into Q by R. This is how we get, the expression for electric potential at any point, okay, when there is a charge configuration plus Q here. So you look at how they are all related. The potential directly proportional to the magnitude of that charge, and this potential is inversely proportional to the distance from the charge. Okay, V and R are inversely proportional. Okay. And it also depends on the potential, also depends upon the medium, okay, medium in which that charge is kept. Since it is air here, we have 4 pi epsilon naught. Epsilon naught, is the constant here. Permittivity of free space. Okay. So this is the expression for electric potential at a point due to a charge configuration, that is plus Q. Shall I explain once again? Yes. So here, look at the diagram, all the data you have to write neatly. There's a charge here plus Q kept at O. At point P, we have to find out the potential V. Okay. This point P is at a distance R from the charge here. Okay. In order to find out the potential at P, we have to keep one charge, that is unit positive charge, at any point, say A, okay, and that charge is at a distance x from the plus Q, okay. So now you have to calculate you can get the electrostatic force between these two charges, okay, from the Coulomb equation for force. Fe is equal to 1 by 4 pi epsilon naught, Q1 is plus Q, Q2 is 1, divided by the distance between them, square of the distance between them, that is x square. This is equation 1. Okay. Now, this charge is to be moved through a distance dx against the field. So, naturally work is done. Let the amount of work done be dw. So, this dw is force into displacement, small amount of work done. Okay. Force into displacement, and that force is Fe here, minus Fe it becomes, because which is opposite to external force. External force is used to move the charge, unit positive charge from A to B. Opposite to that, electric force is there. So, it is minus Fe. Okay. Now, by definition of potential, what is potential? Electric potential at any point. It is the amount of work done in moving unit positive charge from infinity to that point. Okay. So, you get total amount of work done by taking all such summation of all such dWs from infinity to this point P, where you want to find out the potential. Okay. So, how to do that? Integrate. W is integration of dW from infinity to R. dW is how much? Fe into dx, okay, minus, substitute for force, okay, then all these constants you take out, minus 1 by 4 pi epsilon naught into Q, okay. What remains is x to the power minus 2 here. Integration of x to the power minus 2 is x to the power minus 2 plus 1 divided by same power, okay. Minus 2 plus 1 becomes minus 1, that minus 1 and this minus becomes plus, okay, and x to the power minus 2 plus 1 becomes 1 by x, okay, 1 by x. Now, we have to substitute the integrals for this variable, infinity and R. Once you substitute for R and then for infinity, subtract the two terms, okay, this becomes 0, okay. So, what you get is, finally work done. Work done is 1 by 4 pi epsilon naught Q by R. By definition of potential, by definition, that work done is nothing but potential. Work done is nothing but potential. So we got expression for potential 1 by 4 pi epsilon naught into Q by R. Okay, I think it is clear. Again, you have to go through once. Okay, it's the 5-mark derivation. You have to sit and work out by your own by drawing this. Okay, fine. If you want, you can take the screenshot to learn the. I don't know whether you got the notes. Okay, at least you read the textbook. Okay, so you can understand. Huh? So you learned right now the electric potential at a point due to one charge, right? Now we are going for the electric potential due to two charges, but they are not similar charges. They are equal and opposite, similar charges separated by some distance. I hope you can recall that one. It is the electric dipole. So electric potential due to two unlike charges, similar opposite charges separated by some distance. Okay, if there are two charges of that kind, that is electric dipole at a point, what will be the electric potential at any point close by? Okay, this electric dipole that I am going to derive. That is also 5-mark question. There is a concept of graph that I will teach you in the next class. Okay, because I can't continue even derivation also if I take up the graph right now. I will teach the graph concept in the next class, that is tomorrow. Now I am going to derive electric potential at a point due to a dipole. Due to a dipole. Dipole means it is nothing but two charges, okay, they are of equal and opposite charges of same magnitude, plus q here, say another one is minus q. They are separated by some distance, that is distance is 2a, isn't it? This forms a dipole. Okay, 2a is the distance between these two. 2a, okay. Now at any point P, we want to know what is electric potential. At this point, we want to know what is electric potential V at this point. V is how much? At this point, okay. Now what I'll do, I'll join these points, okay, from the charges, plus Q here, and this is minus. Okay. Now, by considering this, dipole as a single system, I will consider a point O at the center here, O, okay, and join this point, okay, join this point P. This becomes the position vector R. This becomes the position vector of this dipole. Okay, it is the distance, R is the distance from O, center of the dipole, to this point P where you want to determine the potential. Let me call this one as say R1 and this one as say R2. Okay, now the dipole moment, what is the dipole moment defined by? Dipole moment P is what? It is the magnitude of one of the charges into product of one of the charges into the separation between the two charges. Okay. So then this becomes A, distance A. This also becomes distance A, 2A, na? That's right. Okay. Then what is the direction? It's a vector. Huh? Dipole moment P, is a vector. Its direction is from negative to positive charge. Negative to positive charge, right? That means from this to this, dipole moment will be there. Okay, that is P vector. Huh? P vector. Okay. So now, what is this angle therefore? Let me take it as theta. What is theta? Theta is the angle between the position vector P and the dipole moment O. Both seems to be P, same no here. Let me take it as something like say A I will take A, B, C. Okay, fine. So what is the theta? Angle between position vector of the dipole and the dipole moment. Okay, theta. Now, what is the potential? It is easy actually to get it. The potential at A is given by V is equal to V1 plus V2. V1 plus V2. V1 is the potential due to charge plus Q and V2 is the potential due to charge minus Q. How much is that? It is 1 by 4 pi epsilon naught, okay, into Q by R. What is the charge here? Plus Q. Plus Q by this R is R1. Okay. Next is plus. Charge is now minus. So minus Q by R2. Okay. This is the total potential at point P. Okay. But I don't know what is R1 and what is R2. That's all is the question. In everything you know except R1 and R2. This R1 and R2 we are writing in the form of electric dipole moment. Electric dipole moment. In that form we will write. That's all. We have to get what is R1, what is R2. That's all. Okay. Fine. To get that, what I will do is here, say, this is R. R is greater than R1. Okay. Now what I'll do by drawing perpendicular here. See, this is total R. Okay. So now this is R1. This is also R1. This one let me take. Okay. I will measure this one. Some point shall I give D or something? D. Okay. If you measure DO, you can understand that. Okay. This R1 is total R minus DO. Okay. From the diagram, what is R1? R1 is total length here R minus this DO. Okay. What is DO? Shall we take? See, this is the if you take the triangle BDO from triangle BDO. See, this is the adjacent side because this is the theta. This is the adjacent side. So cos theta is adjacent by hypotenuse. Adjacent is DO. Hypotenuse is BO. Okay, BO. But BO is equal to this OC, which is equal to A. Okay. So therefore, DO is equal to A into cos theta. DO is equal to A into cos theta. So I got R1. R1 is R minus A cos theta. We got R1. Okay, fine. Now we have to get R2 here. See, R2 we have to get. Okay, with respect to this R. Okay, this R is the position vector of this dipole. Okay. Now what I'll do, in order to get this R2, I will do one arrangement. I will just extend this. Okay, I will extend this till this is equal to R2. Then I will draw perpendicular here. I will draw perpendicular here. Huh? Okay, now this is theta. So opposite side, this is also theta. Okay, now C, D, E or something I'll give. Now I want this R2. R2 is how much? R2 is equal to, this R2 is equal to this R1, see till this to this R1 plus OE. R1 plus, sorry, not R1, it is R. Till this to this, it is R plus OE. Okay, fine. Now we can check what is this OE. Okay, again you can take this triangle. From triangle OCE, okay, cos theta is opposite, sorry, adjacent by hypotenuse. Adjacent is OE by hypotenuse OC. Okay, so I will get OE as OE is equal to OC cos theta. OC is A. Okay, A cos theta. Okay, let me substitute here. That's all. So R2 is equal to R plus A cos theta. Okay, we got R2 also. Almost our job is done because we got R1 as well as R2. We have to substitute here. Okay, we will substitute by taking Q outside. So potential V, okay, is now Q by 4 pi epsilon naught, okay, into 1 by R1, how much? This equation 1 implies now, okay. Equation, from equation 1, we have that R1 is how much? R minus A cos theta, okay, minus 1 by R2. R2 how much? R plus A cos theta. Okay, you carefully observe these two terms. R minus A cos theta. This is R plus A cos theta. Okay, while taking LCM here, their product, it is like in the form A plus B into A minus B. Okay, so V is equal to Q by 4 pi epsilon naught into, this becomes R square minus A square cos square theta. I hope it is clear, my dear students. This is of the form A plus B into A minus B, which is A square minus B square. Okay. Now, while taking LCM, R minus A cos theta cancels. This comes to the numerator. That is A plus R plus A cos theta minus, okay, this positive value R plus A cos theta cancels. What you get in the numerator is R minus A cos theta. But there is minus here. So, minus R plus A cos theta. Okay. Okay. Now, if you look at, see, plus R, minus R cancels. This is A cos theta plus A cos theta, 2A cos theta. So, V is equal to Q by 4 pi epsilon naught into 2A cos theta by R square minus A square cos square theta. Okay. Now, 2A into Q, see here, 2A into Q is P. Okay, electric dipole moment. P is, therefore, V is equal to 1 by 4 pi epsilon naught. 2A into Q is P, so P cos theta by I will write it as r square. That's all. Okay, r square. Why we can do this is a square cos square theta is very, very negligible. Okay, because this dipole, no, this 2a distance is very small actually. Because why? A is very small compared to R. Okay, A is very small compared to R. Hence, this is negligible. A square cos square theta is almost equal to 0, negligible. Okay, this one. Understood? Okay, so we got the potential equation due to a dipole at point A. See how much? V is 1 by 4 pi epsilon naught. P is the electric dipole moment into cos of the angle theta, angle between dipole moment vector and the position vector theta, by square of the distance. See, electric potential was due to one charge was V inversely proportional to R, but here due to dipole it is inversely proportional to square of the distance between the what? This one position vector and the center of the dipole to the position where potential is to be determined. Okay, so this is the derivation. Again I will explain, my dear students, because at once suddenly you can't grasp this one. So I will explain once again by again drawing. I will redraw it once again. Oh, the symbol may change here. A, B, C, D, E. Okay. I will redraw it. Okay. To make you understand once again. Yes. First, what we have to do? We have to consider a dipole. Okay. Dipole, which is constituting two charges of same magnitude and but unlike charges. One is plus q, another one is minus q. Okay. Now let O be the center of the dipole. The distance between two charges is 2a. So this is A, this is also A. Okay. Now I want to determine what? Electric potential at a point A here. Okay. Due to this dipole. So join the center of the dipole to the A, that becomes the position vector of the dipole. This is the position vector of the dipole and its distance is R or R vector from the dipole. Okay, fine. Now join plus Q to A and minus Q to A. Okay, and just denote them by some distance. Here the distance is, let it be R1 and this distance is R2. Okay. Now, electric potential due to the dipole constituting two charges plus Q and minus Q is just the summation. So, here the beauty is it's not a vector. Potential, you find it really easy solving problems also because it is not a vector. You need not worry about which direction and all. Just take positive. If it is a positive charge, potential is positive. If it is a negative charge, potential become positive, negative. So, potential at point A is V1 plus V2 due to these two charges, which is 1 by 4 pi epsilon naught Q by R1 minus, because this is negative charge, Q by R2. Because in the previous section, you learned the expression for potential. So, only thing we have to find out what is R1 and what is R2. We will find out R1, here this R, if you draw the perpendicular from this point, from point B, okay, B to this point here D, we will take it D, perpendicular if you draw, this R is nothing but R1, this distance becomes R1 plus DO, okay, R1 plus DO, or R1 is total R minus DO, okay, because I want R1. R1 is total R minus DO. Okay, now we will find out what is DO. From triangle, this one, BDO, from the triangle, cos theta, cos theta, cos theta is adjacent DO by hypotenuse, that is DO. Okay, this one you got. Now you want DO, so DO is A cos theta because BO is A, BO is A. Okay, so you got R1 as R minus A cos theta. Okay, this is one equation we already got. Now we want R2 also here. We want R2 in terms of R. So what we have to do? We have to draw, extend this one, okay, and draw perpendicular. Okay, like this. Now, if this is theta, this is also theta. Now, total length becomes equal to R2, this one. So, this till this we have R. So, therefore, R2 is R plus EO. Okay. So, R2 is, total this R2 is, this is also R2. R plus EO. Okay, we got this. Now, use this triangle OEC. From that, cos theta is adjacent OE by hypotenuse, that is OC. So, we got OE as A cos theta because OC is again A. Okay, we got this. Okay, now we got both R1 and R2. Only thing is substituting for R1 and R2 and taking mathematical steps. That's all. Okay, fine. So, again, so here A R minus A cos theta, here R plus A cos theta, you have to take the LCM of this. So, when you take, so you get, this is of the form A plus B into A minus B. So, A square minus B square we got. Numerator here you get this one and in this position you get this one. Okay, if you substitute here, R terms will get cancelled. What you get is A cos theta terms, okay, which is 2A cos theta. Okay, and anyhow Q by 4 pi epsilon naught outside and denominator you have so much. Okay, now R is very much greater, this R compared to this A. Okay, so what we have to, when you neglect this A, because A itself is small, A square is still small. Okay, so this term you may have to neglect this one. Okay, so what you get finally, potential at any point A due to this dipole is 1 by 4 pi epsilon naught into P, this Q into 2A, no? It is electric dipole moment. You have studied in the last chapter. Okay. So, electric dipole moment into cos theta by R square. Unlike the previous case, for isolated charge, V and R were inversely proportional to each other. Now, V is inversely proportional to square of the distance, okay, from the position vector. So, this is the position vector. From the center of the dipole to the point where we determine potential, how they are varying. V is inversely proportional to square of the distance. Okay. So, my dear students, please learn this also and come to the next class, that is tomorrow. So, I will discuss, the different, what happens when theta is changed. Okay. Theta 0 degree, what happens? Theta 90 degree, what happens? And theta 180 degree, how the potential changes. And also one graph I have to explain on based on this. Okay, my dear students, please learn and come to the next class. Thank you. Oh, sorry, I got confused with the timing. It's 11:10 to 12:10, I think. Okay. I was little, I rushed up little. Okay. I hope it is clear, my dear students. You just go through once again all the steps. Okay. The diagram you have to draw properly. Okay. This distance is R and this distance is R1. Okay. And this one, OD is A cos theta. Okay. A cos theta. This OA is also then A cos theta. Both DO and OE both are A cos theta. Okay. So therefore R2 if you want, it is R plus A cos theta. R1 if you want, it is R, okay, R1 if you want, it is R, total R minus A cos theta. That's all is the difference. Huh? Okay. Now we will see what happens when you change theta. Okay. How to change theta? See, just the position vector, okay, of this dipole with this point, that is to be changed. So if theta 0 degree means this A will come, on the axial line. Okay, theta 0 degree. Okay, now we will see what happens. Okay, first one, on the axial line, that's on the axis. Two possibilities. If you take this one, this point A on negative x-axis, theta will become 0 degree. First one in that. When theta is 0 degree. When theta is 0 degree, what happens to the potential? Potential due to a dipole 1 by 4 pi epsilon naught 2 p cos theta, p cos theta by a square, r square. Okay, when theta is 0 degree, that is when the point where you want to determine the potential is on the axial line. Okay, V becomes, okay, cos 0 degree is 1. So V is equal to 4 pi epsilon naught into P by R square. Okay, this is the V is positive. So V is positive. Okay. Now the second one, when theta is 180 degree, if this point is on the positive x-axis, okay, on the positive x-axis, then theta becomes 180 degree. Then what happens? V is equal to, see here, cos of 180 degree how much? Minus 1. Okay, so it is minus 1 by 4 pi epsilon naught P by R square. V is negative now. Okay, theta 180 degree, cos 180 degree is minus 1. Okay, next second one part, on the equatorial line. What happens to the potential? We have to check. If the equatorial line means this A will go exactly above this O. Okay. So at that point, what is the potential due to this dipole? We have to get. That is when theta is 90 degrees, isn't it? If you just align this R position vector exactly perpendicular to this dipole, then theta becomes equal to 90 degree. Okay. When theta is 90 degree, look at, cos 90 degree is 0. So V is 0. Potential on the equatorial line becomes equal to 0. Okay. These are the three things. Okay. I hope it is clear, my dear students. Please go through once. We don't have much time. Just 5 hours is given to me to do electric potential. So definitely it won't be enough. Okay. So I will take extra class and finish it off. So that's why little, I might have hurried today. Please go through the 2 derivation that I taught you. Okay.
ಏನಮ್ಮ ಏನಮ್ಮ 2 ರೂಪಾಯಿ 3 ರೂಪಾಯಿ
haloarenes. We have already learned preparation of haloarenes in the beginning itself, in the preparation of haloalkane. Along with that, haloarenes also we have studied, where starting from hydrocarbon, how do you prepare? That is for an aromatic hydrocarbon, say for example, when toluene is treated with chlorine in the absence of sunlight, or sorry, in the presence of sunlight, it undergoes a side chain halogenation. That is benzyl chloride. If you want to prepare chlorobenzene, that is in the absence of sunlight, iron catalyst, the chlorine is substituted in the ring. We have studied already. Only the properties we will be studying. Haloalkanes properties we have completed last class. That is a reaction with the metals. One is a Grignard reagent, other one is with sodium metal. Wood's reaction we have studied. Today, haloarenes. Physical properties also we have studied. Generally, dihaloarenes, isomeric dihaloarenes will have almost the same boiling point. Only the melting point will vary. And that is, the para isomer will have higher melting point than ortho and para, because ortho and meta. This is because of symmetry in the molecule. You can see the symmetry is nothing but, if this is para, okay, this can be easily inserted into another molecule. So there is symmetry in the molecule because it fits into crystal lattice. Hence, a higher temperature is required in order to melt this compound. So that is the only physical property we are supposed to remember. Chemical properties. Coming to chemical properties. Here, as you have seen, chlorobenzene structure I had written. Okay. Now, the halogen atom is bonded to carbon atom of the ring. Though we represent by a single bond, it is not actually bonded with a single bond. That is, aryl halides. Aryl halides are less reactive than haloalkanes or alkyl halides. Towards substitution reactions, SN reactions, you can say. Why? Less reactive, why? There are 4 reasons. One reason is resonance effect. The halogen atom possesses 3 lone pair electrons, which is in conjugation with the double bond. You can see alternate double bonds, double bond, single bond, lone pair. That is in conjugation. Naturally, this also involves in the resonance, number of resonance structures. So it will be, the double bond will be keep on moving, and you will have a double bond character here. So due to that resonance, the halogen atom is strongly held by the benzene ring, not easily replaceable as in case of haloalkane. So first reason is resonance effect, hence less reactive we say. That is, the lone pair electrons of halogen is in conjugation with the double bond of benzene ring. Because of that, the halogen atom is having partial double bond character in case of haloarenes. Whereas in case of haloalkane, it is single bond only. Hence, the bond becomes short and strong. Strong and short. The bond length also decreases. 169 ಬಂದ್ಬಿಡುತ್ತೆ. Haloalkanes alladre halogen and this one is 177 picometer ಇದ್ರೆ ಅದೇ ಕಾರ್ಬನ್ halogen bond haloarenes ಅಲ್ಲಿ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ ಬಿಕಾಸ್ ಆಫ್ ದಿ ಡಬಲ್ ಬಾಂಡ್. ಅಂದ್ರೆ ಸಿಂಗಲ್ ಬಾಂಡ್ ಇದ್ರೆ ಬಾಂಡ್ ಲೆಂತ್ ಯಾವಾಗಲೂ ಜಾಸ್ತಿ, ಡಬಲ್ ಬಾಂಡ್ ಇದ್ರೆ ಬಾಂಡ್ ಲೆಂತ್ ಕಡಿಮೆ. ಆಮೇಲೆ ಸ್ಟ್ರೆಂತ್ ಹೇಳೋದಾದ್ರೆ ಸಿಂಗಲ್ ಬಾಂಡ್ಗೆ ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ಕಡಿಮೆ, ಡಬಲ್ ಬಾಂಡ್ಗೆ ಬಾಂಡ್ ಸ್ಟ್ರೆಂತ್ ಜಾಸ್ತಿ. ಇಲ್ಲಿ ಡಬಲ್ ಬಾಂಡ್ ಕ್ಯಾರೆಕ್ಟರ್ ಬರೋದ್ರಿಂದ ಓಕೆ ಇಟ್ ಬಿಕಮ್ಸ್ ಸ್ಟ್ರಾಂಗ್, ದ ಬಾಂಡ್ ಬಿಕಮ್ಸ್ ಸ್ಟ್ರಾಂಗ್ ಅಂಡ್ ದ ಬಾಂಡ್ ಲೆಂತ್ ರೆಡ್ಯೂಸಸ್. ಓಕೆ, ಬಿಕಾಸ್ ಆಫ್ ದಟ್ ಇಟ್ ಈಸ್ ಲೆಸ್ ರಿಯಾಕ್ಟಿವ್. ದಿಸ್ ಇಸ್ ಒನ್ ರೀಸನ್. ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ ಇದನ್ನ. ಹಾಗೆ ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ಹೇಳೋದಾದ್ರೆ type of hybridized carbon is one more reason. Carbon in CX bond. See, in case of haloalkane, say for example CH3 Cl ide, hage C6H5 Cl. If you consider all the carbon atoms are sp2 hybridized in benzene ring, as you know, every carbon atom is one or the other way have got the double bond. Whereas in this it is sp3 hybridized. We have seen, isn't it? Single bond. So it is sp3 hybridized carbon. Whereas in this case it is sp2 hybridized carbon holding the halogen atom, which is having more S character. Percentage of S character is more, whereas percentage of S character is less. Idralli 25% idre idu 33% S character. So as the S character increases, electronegativity also increases and strongly held by the such carbon atom. Therefore, aryl halides are less reactive than haloalkane. This is another. Give two reasons anta keltare. Minimum iveradaadru kaltirbeku. Ondu resonance of the lone pair electrons of halogen atom involve, that is in conjugation with the double bond of benzene ring. Because of that, okay, the halogen atom is bonded to ring carbon atom through a partial double bond character, and hence bond strength is more, whereas bond length decreases, the bond becomes short, hence it is difficult to substitute or replace the halogen atom by other nucleophile. So hence it is less reactive in case of aryl halides. Whereas one more reason is type of hybridized carbon atom holding the halogen atom. That is, in case of haloalkane, the halogen atom is bonded to a sp3 hybridized carbon atom having less S character. Okay, hence electronegativity is less and little loosely held by the carbon atom in case of haloalkane. Whereas in case of haloarene, the halogen atom is bonded to an sp2 hybridized carbon atom which is having more S character, so more electronegative, more strongly hold the halogen atom. Hence, in case of aryl halides, the reactivity is less towards the substitution reaction. Third reason, generally reaction ಆಗಬೇಕು ಅಂದ್ರೆ ಈ ಕಾರ್ಬನ್ ಹ್ಯಾಲೋಜನ್ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗಬೇಕು ಈ ರೀತಿ, ಹೌದಾ? ಸೊ ಇನ್ ಕೇಸ್ ಆಫ್ C6H5Cl, if self ionization occurs, means you get carbon possessing the positive charge, correct? When the bond breaks here, a positive charge develops. Idu C6H5, idನ್ನ ಏನಂತ ಕರಿತೀವಿ? Phenyl cation. Okay, due to self ionization, if carbon halogen bond undergoes self ionization, then results in the formation of phenyl cation. This phenyl cation, when you look, it is not in conjugation with the double bond, hence it is not stabilized by resonance. Stability iralla, phenyl cation ge stability illa. Because of that, it is less reactive, we call it. One more reason is, fourth reason, benzene itself is rich with pi electrons, correct? And if you are making it to attack by the nucleophile, there will be repulsion between the electron-rich benzene ring and the electron-rich nucleophile. What is meant by a nucleophile? Nucleophile is nothing but electron-rich species. So, attack of this electron-rich species on electron-rich benzene ring is not possible. Because of that, the substitution reaction occurs in slower rate. ಅಥವಾ ಆಲ್ಮೋಸ್ಟ್ ನಿಲ್ ಅಂತಾನೆ ಹೇಳ್ಬೋದು. ದೀಸ್ ಆರ್ ದ 4 ರೀಸನ್ಸ್. ಇದರಲ್ಲಿ 2 ರೀಸನ್ ಅಂತೂ ಚೆನ್ನಾಗಿ ನಾವು ಕಟ್ಕೊಳ್ಳಿ. ಒಂದು ರೆಸೊನೆನ್ಸ್ ಎಫೆಕ್ಟು, ಇನ್ನೊಂದು ಟೈಪ್ ಆಫ್ ಹೈಬ್ರಿಡೈಸ್ ಕಾರ್ಬನ್ ಆಟಮ್. ಓಕೆ, ದಟ್ ಈಸ್ 2 ರೀಸನ್ ಸಾಮಾನ್ಯಕ್ಕೆ ಕೇಳೋದು. ಇವೆಲ್ಲಾದ್ರೂ ಕಲ್ತ್ಕೊಂಡಿರಿ. ಇಲ್ಲಿ ಏನ್ ಹೇಳಬೇಕು? ಡ್ಯೂ ಟು ರೆಸೊನೆನ್ಸ್ ಎಫೆಕ್ಟ್, ಓಕೆ, ದ ಲೋನ್ ಪೇರ್ ಆಫ್ electrons in halogen atom of haloarine is in conjugation with the double bond of benzene ring, hence undergoes resonance, and it acquires a partial double bond character, and hence the bond becomes strong and short. So naturally the cleavage of carbon and halogen bond becomes difficult, hence aryl halides are less reactive towards the substitution. Second reason, in case of haloalkane, the halogen atom is bonded to an sp3 hybridized carbon, which is having less S character, hence the electronegativity is less, and CCl carbon halogen bond is not so strong as in case of haloarine, where the halogen atom is bonded to an sp2 hybridized carbon atom of benzene ring having more S character, and hence it is strongly held by the benzene ring, and it is not so easy to replace it. Hence aryl halides are less reactive towards the substitution. Third reason, not so important as in case of these two. Okay, here generally to undergo substitution, the carbon halogen bond has to break. So breaking of halogen and carbon bond, if suppose occurs in case of haloarine, it results in the formation of a phenyl cation, which is not stabilized by resonance. So naturally substitution reaction cannot occur. Generally haloalkanes alli ನಾವು more stable carbocation always prefers the nucleophilic attack. ಅದಕ್ಕೆ for SN1 ಆಗಬೇಕು ಅಂತಂದ್ರೆ tertiary carbocation more stable ಅಂತ ಹೇಳ್ತೀವಿ. Tertiary halides are more preferring the SN1 mechanism ಅಂತೀವಲ್ಲ. ಇಲ್ಲಿ ಯಾವುದೇ ಸ್ಟೆಬಿಲಿಟಿ ಇಲ್ಲದೆ ಇರೋದ್ರಿಂದ phenyl cation cannot undergo substitution reaction. Fourth reason ಏನಂದ್ರೆ benzene itself is rich with electrons and nucleophile is an electron rich species. Attack of electron rich species on electron rich benzene ring is causing the repulsion between the electrons. Because of that, the substitution reaction becomes difficult. So due to all these reasons, aryl halides are less reactive towards the substitution reaction. Now, we will go for, so after this reason, however, haloarenes also undergo substitution reaction. That means the halogen atom of haloarene can be replaced by a nucleophile. Okay. Nucleophilic substitution reaction of haloarene. ಇದು first chemical property. Chlorobenzene example. Sir, class ಅಲ್ಲಿ ಇದ್ದೀನಿ. ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇದ್ದೀನಿ. Chlorobenzene, when heated with aqueous sodium hydroxide to 623 Kelvin, see such a high temperature we are supposed to use, and 300 atmosphere pressure, okay, followed by acid hydrolysis, results in the substitution of hydroxyl group in place of halogen. That results in the formation of phenol. Look at the condition: high temperature, high pressure is required to make it to undergo substitution reaction. That is why aryl halides are less reactive towards substitution reactions, we say. However, this can be made easily undergoing substitution by introducing electron withdrawing groups. Electron withdrawing groups, suppose if you are considering nitro group, which is an electron withdrawing group, the same reaction, if you treat with aqueous sodium hydroxide, only this much temperature is sufficient, 443. You need not to apply any pressure. Okay, this can easily undergo reaction. This is the first part, and followed by acid hydrolysis. Here you get the substituted product. Halogen is replaced by hydroxyl, which is the nucleophile over here. If suppose there are two electron withdrawing groups are present, okay, the same reaction NaOH aqueous, temperature is less, still less temperature you can apply these electron withdrawing group, helps in making it to undergo substitution reaction, so that means the substitution reaction becomes easier by the introduction of these electron withdrawing group. Third, if 3 electron withdrawing groups are there, you need not to use sodium hydroxide to provide the hydroxide. Just if you warm with water andre H2O, okay, simply if you warm, substitution becomes very easy. You need not to take an alkali, just if you warm with water, andre temperature ishtu bekagilla, 368 Kelvin bekagilla. Look at the difference. If there are no other groups influencing this halogen atom, high temperature, high pressure is required. If there is an electron withdrawing group present, then a little less temperature is sufficient. You need not to apply any pressure over here. 2 more electron withdrawing, that is 1 more electron withdrawing group. If you introduce in the benzene ring, still less temperature is required. If there are 3 electron withdrawing groups present in that halo array, you need not to take a particular nucleophile. Simply, if you warm with water also, you can bring about the substitution reaction. Why? This is being asked even in CET, okay? The introduction of electron withdrawing group at ortho and para. You can see at ortho and at para position. Alli 2 ortho, 1 para position. Ella ortho matte para position occupy agirodu. That will in fact decreases the electron density, so that substitution becomes easy for halogen atom. That is the reason. Okay, it decreases the electron density in the benzene ring and facilitates the substitution reaction. Okay, take down. Okay. Now, next chemical property. This is nucleophilic substitution reaction we have studied. Second chemical property, electrophilic substitution reaction. Of halon arrays. This is SN reaction, this is ESR, you can say, electrophilic substitution reaction. Generally, whenever you have a benzene ring, electrophilic substitution is common. Okay. Nucleophilic substitution, I have told you there are 4 reasons why it is less reactive. Hence, we are applying so many drastic conditions in order to undergo nucleophilic substitution reaction. Now, electrophilic substitution reaction, if you compare chlorobenzene and benzene, okay, benzene is more reactive, whereas chlorobenzene is less reactive towards the electrophilic substitution reaction. What is the reason? This is causing negative inductive effect. Okay, causing negative inductive effect, and of course resonance effect is also there, and electron density you find at ortho and para position. Okay, you find the electron density at the 2 ortho position and para position. So ortho para directing. If an electrophile is substituted with respect to this, either at ortho or at para, the substitution takes place. Why only at those positions? Because the electron density we find at ortho and para directions. Hence, it is ortho para directing, but it, due to that negative inductive effect, it deactivates the ring at ortho and para position. What are those usual electrophilic substitution reaction? On the whole, we will write like this. Okay. Halogenation, nitration, sulfonation, Friedel-Crafts alkylation, and Friedel-Crafts acylation. First one, halogenation. Okay, halogenation. Illi halogen in the presence of anhydrous ferric chloride catalase. Okay, that is the Lewis acid acting as the catalyst over there. So where that Cl plus ion substitutes in the benzene ring, no change in this halogen. At ortho and at para, chlorine atom is substituted. I mean chloronium ion. So we can write for this, what is the name? 1, 2, this is position 1 and 2, this is 1 and 4. So here 1, 2, and this is 1, 4. Dichlorobenzene is obtained as the product. An ortho product, and athwa higu helbodu ortho dichlorobenzene, para dichlorobenzene anbodu. Systematic name helodadre number kotkoli 1 and 2. At the first and second position 2 chlorine atoms, 1, 2 dichlorobenzene, and at 1 and 4 2 chlorine atoms. So 1, 4 dichlorobenzene. Next, nitration. The reagent for nitration is concentrated nitric acid and concentrated sulfuric acid mixture on heating. What is the electrophile here? The electrophile is nitro group at ortho position, and at para position it is substituted. And of course, While giving the IUPAC name for this, look at the order of preference for this. For halogen first preference and for nitro group second preference. That is why 1 and 2. Here 1, 2, 3, 4. This we can say 1 chloro, 2 nitro benzene. Whereas the second one is 1 chloro, 4 nitro benzene. Nitronium ion is substituted in the benzene ring at ortho and para position. Similarly, if you do heat with sulfonation, idna nitration anbodu. Second one eno nitration. Iga third one eno sulfonation. Sulfonation ge reagent eno concentrated sulfuric acid. So on heating with concentrated sulfuric acid, the sulfonic acid group is substituted at ortho and para position. So this is the major functional group. When there are two functional groups, you have to see which is the major. The name should end with this only, sulfonic acid group. And if that is the case, numbering from here 2 and 1, 2, 3, 4. This is 2-chloro benzene sulfonic acid. Name should end with that major functional group, sulfonic acid. And this is 4-chloro benzene sulfonic acid. Okay. Now, fourth one, Friedel-Crafts alkylation. Alkylation. What is the reagent here? Chloromethane in the presence of anhydrous aluminum chloride. Friedel-Crafts main catalyst anhydrous aluminum chloride. In the presence of that, the alkyl group is substituted at ortho position and para position. So CH3 group at ortho position and at para position. What is the name for this? The name of this is nothing but here order of preference kododadre halogen ge first ಆಮೇಲೆ methyl group ge ಹಾಗಾಗಿ 1-chloro 2-methyl benzene ಅದು 1-chloro 4-methyl benzene. 1-chloro 2-methyl benzene, and this is 1-chloro 4-methyl benzene. Common name you can write orthochlorotoluene. This is nothing but toluene. Parachlorotoluene. Common name. Okay. That is the common name. And one more, I'll write this side. Okay. I think you can able to see. Friedel-Crafts acylation. One more. ಅಲ್ಲಿ alkylation, alkyl group introduce ಮಾಡೋದು, ಇಲ್ಲಿ acetyl group introduce ಮಾಡೋದು. What is the reagent? Acetyl chloride and the catalyst is same, anhydrous aluminum chloride. Here you get mixture of Cl, COCH3, okay, plus at para position Cl COCH3. Now look at the two functional groups, halogen atom and a ketone functional group. Which is major? Definitely ketone functional group. If you remove this, the name of this molecule is acetophenone. This is also acetophenone. So numbering starts from ketone functional group and this becomes the prefix. So what is the name of this? This is nothing but 2-chloroacetophenone and this is 4-chloroacetophenone. So all of these are electrophilic substitution reactions. ಏನು electrophilic substitution ಅಂದ್ರೆ benzene ring ಅಲ್ಲಿ substitution ಆಗೋದು. ಯಾವುದು benzene is rich with pi electrons, ಅದಕ್ಕೆ electrophile substitute ಆಗುತ್ತೆ ಇಲ್ಲಿ. So at what position? Ortho para directing because of the first functional group. ಯಾವುದು halogen atom ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ. Okay, it is ortho para directing but deactivating group ಯಾಕಂದ್ರೆ negative inductive effect produce ಮಾಡ್ತಾ ಇದೆ, ಹಾಗಾಗಿ ಅದು deactivating the ring at ortho and para position. That is why all ortho and para substituted products we got it. First one halogenation we got 1,2-dichlorobenzene and 1,4-dichlorobenzene. What are the reagents? Chlorine and anhydrous ferric chloride. And in the nitration, what is the nitration mixture? Concentrated nitric acid and concentrated sulfuric acid. Nitro group is substituted at ortho and para position. What is the name of this compound? 1-chloro-2-nitrobenzene and that is 1-chloro-4-nitrobenzene. Then sulfonation, third one, where the reagent is concentrated sulfuric acid. So the sulfonic acid group at ortho position and para position it is substituted. So what is the name of this? 2-chlorobenzene sulfonic acid. The name should end with the major functional group. Major functional group is this and that should be a suffix to the root word. You know this is prefix, this is root word and this is the suffix. ಅದಕ್ಕೆ name should end with sulfonic acid only. That cannot act as a prefix. ಈ functional group ನೋಡಿ ಇವೆರಡು prefix ಆಗಿ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ, ಅಲ್ಲಿ ಆರ್ಡರ್ ಮೇಲೆ ನಾವು ಪೊಸಿಷನ್ ಕೊಡ್ತೀವಿ. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಒಂದು ಪ್ರಿಫಿಕ್ಸ್ ಇನ್ನೊಂದು ಸಫಿಕ್ಸ್. ಓಕೆ, ಎರಡು ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ. ಹಾಗಾಗಿ 2-chlorobenzene sulfonic acid and this is 4-chlorobenzene sulfonic acid. Then Prudel-Crafts alkylation. Alkylation ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಏನು ಆಲ್ಕೈಲ್ ಗ್ರೂಪ್ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಆಗೋದು. ಸೊ ಇಲ್ಲಿ ಕ್ಲೋರೋಮೀಥೇನು anhydrous aluminum chloride is the catalyst for always Prudel-Crafts reaction, whether it is acylation or alkylation. The catalyst is same, anhydrous aluminum chloride. In case of alkylation, haloalkane ತಗೊಂತೀವಿ. So this alkyl group is substituted at ortho position and at para position. So what is the IUPAC name of this? Among these two, which is the major functional group? Chlorine. ಅದಕ್ಕೆ ನಂಬರಿಂಗ್ ಅಲ್ಲಿಂದ ಶುರು ಮಾಡ್ಕೋಬೇಕು. Okay, that is why 1-chloro-2-methyl benzene you got and 1-chloro-4-methyl benzene. Prudel-Crafts acylation, here acetyl chloride in presence of anhydrous aluminum chloride, you get 2-chloroacetophenone, 4-chloroacetophenone. Why the name end with acetophenone? Because the ketone is the major functional group, the name should end with that only. Hence it is ONE. For ketone, what is the suffix? ONE. That is why acetophenone. And the name is this. Please copy down all of these equations now. ನೀವು ಇಂಡಿವಿಜುವಲ್ ಆಗು ಬರೀಬಹುದು. ನಾನೆಲ್ಲ ಸೇರಿಸಿ ಬರ್ದಿದ್ದೀನಿ. ಒಂದೊಂದೇ ಸಪ್ರೇಟ್ ಈಕ್ವೇಶನ್ ಬರೀಬಹುದು. When you come to offline classes, we will be giving the printed notes for all these, whatever the chapters we are covering. Okay. That is why we are not sending any PDF, but equations you have to write and practice. That is why you are supposed to copy down from the board. The last reaction of haloarenes is reaction with metal. Just like haloalkane, even the haloarenes can react with metal. There are two types of reaction. One is Woods reaction. The other one is Woods-Fittig reaction. ಇಲ್ಲಿ ಹ್ಯಾಲೋ ಆಲ್ಕೇನ್ಸ್ ಎಲ್ಲ ಆದ್ರೆ ನಾವು ವುಡ್ಸ್ ರಿಯಾಕ್ಷನ್, ಎರಡು ಹ್ಯಾಲೋ ಆಲ್ಕೇನ್ಸ್ ಇದ್ರೆ ಅಂತ ಕರಿತೀವಿ. ಇದನ್ನ ಬರೀ ಫಿಟ್ಟಿಗ್ ಅಂತಾನೆ ಕರಿತೀವಿ. ಇಲ್ಲಿ ಹ್ಯಾಲೋ ಅರೀನ್ಸ್ ಎಲ್ಲ ಆದ್ರೆ ಫಿಟ್ಟಿಗ್ಸ್ ರಿಯಾಕ್ಷನ್. ಓಕೆ, ಫಿಟ್ಟಿಗ್ಸ್ ರಿಯಾಕ್ಷನ್ ಅಂಡ್ ವುಡ್ಸ್ ಫಿಟ್ಟಿಗ್ reaction. First one, Fittig's reaction. Fittix reaction alli haloarine when treated with sodium metal in the presence of dry ether gives higher aromatic hydrocarbon. Okay, so shall I rub this? ಇಲ್ಲಿ ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಳೋದಾದ್ರೆ say chlorobenzene when treated with sodium metal okay in the presence of dry ether okay give of course warm ಬೈಫಿನೈಲ್ ಅಂತ ಆದ್ರೂ ಹೇಳ್ಬೋದು, 2 ಫಿನೈಲ್ ಗ್ರೂಪ್ ಅಥವಾ ಡೈಫಿನೈಲ್ ಹೇಳ್ಬೋದು ಇಲ್ಲಿ sodium chloride. This reaction is known as Fittix reaction. ನೋಡಿ Woods reaction ಅಂದ್ರೆ 2 ಹ್ಯಾಲೋ ಆಲ್ಕೇನ್ ಅಲ್ಲಿ ಇಲ್ಲಿ ಹೇಗೆ 2 ಹ್ಯಾಲೋ ಅರೀನ್ ಇದೆಯೋ ಅದೇ ತರ 2 ಹ್ಯಾಲೋ ಆಲ್ಕೇನ್ ಇದ್ದು ವಿತ್ ಸೋಡಿಯಂ ಮೆಟಲ್ ಇನ್ ಡ್ರೈ ether gives higher alkene. Whereas in case of haloarine, 2 haloarenes, 2 molecules of haloarenes react with sodium metal to form the higher aromatic hydrocarbon. This reaction is known as Fittix, whereas 2 haloalkane idre Woods reaction antivi. 2 haloarene idre Fittix reaction anta kariತೀವಿ. ಅದೇ ಒಂದು haloalkane ಇನ್ನೊಂದು haloarene idre Woods Fittix reaction. We call it as Woods Fittix reaction. Combination of Woods reaction and Fittix reaction. Here, say chlorobenzene with sodium metal and chloromethane. One haloalkane, one haloarene. Okay. In the presence of dry ether, okay, on warming, this is just like aryl alkyl, ಎರಡು combine ಆಗಿ ಬರೋ hydrocarbon. Okay, and this is nothing but toluene, higher aromatic hydrocarbon ಅಲ್ವಾ, ಒಂದು alkyl group ಇಲ್ಲಿ substitute ಆಗಿರುತ್ತೆ. This is from Woods reaction. Woods ಅಲ್ಲಿ ಏನು 2 halo alkane ಇರುತ್ತೆ, ಅದ್ರ ಬದಲು ಒಂದು halo alkane ಇನ್ನೊಂದು haloarene in the presence of sodium metal and in a dry ether gives you aralkyl compound. Aralkyl ಅಂದ್ರೆ aryl group ಇದೆ, alkyl group ಇದೆ. ಇದನ್ನ Woods Fittix reaction. Name reactions are very, very important. You have to list out all the name reactions appearing in this chapter and be prepared for it. 8 mark questions will come on only name reactions. Especially only in this chapter you find many name reactions. Okay, ನೀವು ಸಪರೇಟ್ ಆಗಿ ಒಂದು ಬುಕ್ ಇಟ್ಟು ಎಲ್ಲ ನೇಮ್ ರಿಯಾಕ್ಷನ್ ಲಿಸ್ಟ್ ಮಾಡ್ಕೊಂತ ಹೋಗಿ ಒಂದೊಂದೇ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಎಕ್ಸಾಮ್ಗೆ ಅದನ್ನ ಓದ್ಕೊಂತ ಹೋದ್ರೆ ಖಂಡಿತ ನಿಮ್ಗೆ 8 ಮಾರ್ಕ್ಸ್ಗೆ ಈ ನೇಮ್ ರಿಯಾಕ್ಷನ್ಸ್ ಆಲ್ ಓವರ್ ಕ್ವಶನ್ ಪೇಪರ್ ಅಲ್ಲಿ ಇದ್ದೇ ಇರುತ್ತೆ. This completes the haloarenes. Now polyhalogenated compound, tomorrow I will do it. Please copy down this. Tomorrow we will test the annual exam question paper. Okay. Please go through whatever I have done so far and come ready. ಇನ್ನೊಂದು 10 ನಿಮಿಷದ ಸಿಲೆಬಸ್ ಇದೆ ಅಷ್ಟೇ, ಅದನ್ನ ಮಾಡಿ ಆಮೇಲೆ ಕ್ವಶನ್ ಪೇಪರ್ನ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ ನಾಳೆ. ಓಕೆ, ಅಲ್ಲಿಗೆ ಈ ಚಾಪ್ಟರ್ ಕಂಪ್ಲೀಟ್ ಆದಂಗಾಯ್ತು. ಅಯ್ಯೋ ನಾನು ನೋಡಿ ಹೋಗ್ತಾ ಇದ್ದೀನಿ.
Good afternoon, students. So in the last class, that is in the Monday class, we have started with the female reproductive part, isn't it? So in this, we have discussed pistil, structure of the pistil, and about the different types of ovary, that is syncorpus ovary, apocarpus ovary. So then with the relevant examples for that particular topic, so we have discussed that, and again we have started with the arrangement of ovules inside the ovary. So that process is called as placentation, isn't it? The arrangement of ovules inside the ovary on a cushion-like structure called as placenta. So that process is called as placentation, and we have discussed with different types of placentation also. And lastly, we have started with a very important question, that is the structure of a megasporangium or a structure of a ovule, isn't it? So ovules, after fertilization, they will get turned as a seed, and after fertilization, ovary will get turned as a ovum. Okay, so this is what we have discussed, and we have discussed the structure of the ovule, isn't it? The structure of the ovule consisting of how the embryo sac has been formed inside the ovule. Okay, so this is what we have discussed. Innermost layer we have embryo sac, and on that the innermost layer is called as nucellus. Nucellus is very rich in nutrients, so that it is involving in providing nutrition for the developing embryo. Okay, next this embryo sac along with the nucleus, sorry, not nucleus, nucellus. So this is covered by two protecting layer, that is called as what? Outer integument and inner integument layer. Okay, so here and there, and the small pore is there, that the integument covering is absent. So that particular region is said to be what? Micropyle. So what's the function of the micropyle here? It involves in the exchange of gases, and it involves in the seed dormancy by removing 50% of the total weight of the seed. Okay, next, after formation of seeds, I'm telling this. Next, what is the main function? It involves in the exchange of gases as well as absorption of water, moisture content from the surrounding atmosphere. Okay, so this is what the structure of the ovule consists of. And the stalk of the ovule is called as what? Funicle. Funicle get attaches to the ovule by a structure or a junction called as what? Hilum or seed. Isn't it? So this is what we have discussed in the Monday class, that is day before yesterday class. Okay, so now what we are going to do, how the embryo sac has been formed inside the structure of the ovule, and the process is called as, okay, so as such of microsporogenesis, that is the formation of microspores from pollen mother cell or microspore mother cell through a process called as meiotic cell division, isn't it? So as such of microspores are forming through microsporogenesis, here the process called as megasporogenesis. It is that megasporogenesis involves in the formation of megaspores, and the cells which involves in the formation of megaspores are called as what? MMC, that is megaspore mother cell. Okay, what does it call? Megaspore mother cell. How this is forming? We have to study how the megasporogenesis takes place and where it will take place, and how the embryo sac is formed inside the structure of the ovule. Okay. Sexual reproduction in flowering plants. And that we are going to discuss about the topic called as what? Megasporogenesis. What is the definition for this here? Name only indicates genesis means synthesis. What is synthesizing here? Megaspore. Hence, the process is said to be what? Megasporogenesis. The process of formation of megaspores from megaspore mother cell through meiotic cell division. So, this process is called as what? Megasporogenesis. Okay. So, how the megaspore mother cells are involving in this process? That is the question for us. Okay. One of the cells of the nucleus region. One of the cells of the nucleus region will protrude through the micropylar end. Okay. So, nucleus region ಒಂದು cells ಗಳೇನಾಗ್ತವೆ micropylar region ಇಂದ protrude ಆಗಿ ಅಲ್ಲಿ changes ಆಗಿ ಅದು ಮಿಯೋಟಿಕ್ ಡಿವಿಷನ್ ಅಲ್ಲಿ ಇನ್ವಾಲ್ವ್ ಆಗಿ ಏನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತವಂತೆ ಮೆಗಾಸ್ಪೋರ್ಸ್ ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತವೆ. So that process is called as what? Megasporogenesis. Okay. So let's see with a diagrammatic representation how the megaspores are forming. Yeah. One of the cells of the nucleus will protrude through the micropylar region. So this is nucleus layer. From this, a single megaspore mother cell will protrude through the micropylar end. Okay, so this is a megaspore mother cell. After that, in the second diagram, this megaspore mother cell involves in first meiotic division, that is meiosis 1, and result in the formation of 2 daughter cells. Okay. This is megaspore dyad. Dyad means what? It consists of two cells. So first single megaspore mother cell involves in meiotic 1 cell division. Meiosis 1 cell division and result in the formation of two daughter cells which are called as what? Megaspore dyad. Dyad means it's consisting of how many cells? Two cells. Later on, these two cells involves in second meiotic division and result in the formation of 4 megaspores. Okay. See, megasporogenesis involves in the formation of megaspores from megaspore mother cells through meiotic cell division. Okay, so this inside the egg ovary, so a nucleus region, one of the cells of the nucleus region will protrude through the micropylar region, and this megaspore mother cell involves in meiosis 1 and produces how many cells? 2 cells. Okay. The condition of the megaspore is said to be megaspore dyad. Why? Because it's consisting of 2 cells. It results in the formation of 2 daughter cells. Later on, these 2 cells involves in second meiotic division, that is meiosis 2, and involves in the production of 4 daughter cells. That is 4 megaspores are formed as such of microsporogenesis itself. Isn't it? Okay. So these 4 megaspores have the capacity to involve in the formation of an embryo sac. Okay. In microsporogenesis, the microspores which are formed are associated with each other, hence they are called as microspore tetrad. Alva? So this microspore tetrad, later on, they will dissociate with each other and each microspore will involve in the formation of a pollen grain. Whereas here in megaspore, all the megaspores have the capacity to develop the embryo. But among the 4 megaspore, only one functional megaspore will be developing as a female gametophyte or embryo sac. Then what about other 3? The remaining 3 will be degenerated. Okay. Usually, embryo sac of female gametophyte development takes place from a single megaspore. Other 3 will be degenerated. Hence, this condition is said to be what? Monospory. What is that? Monospory. What's the meaning of that? Monospory. Mono means what? Single. Spory means spore. So the formation of embryo sac takes place by the single megaspore. Okay. So this condition is called as what? Monospory, and the development is said to be monosporic development. Okay. So the formation of embryo sac from a single megaspore is called as monospory, and the development is said to be what? Monosporic development. Yeah. So this is how the embryo sac formation takes place. Will start from here. So this is how the embryo sac formed from a megaspore. So how the megaspores are formed? Like this, through a process called as megasporogenesis. ಇಲ್ಲಿ ತನಕ ಮೆಗಾಸ್ಪೋರ್ಸ್ ಹೇಗೆ ಫಾರ್ಮೇಶನ್ ಆಯಿತು, ಹಾಗೇನೆ ಆ ಮೆಗಾಸ್ಪೋರ್ಸ್ ಹೇಗೆ ನೆಕ್ಸ್ಟ್ ಎಂಬ್ರಿಯೋ ಸ್ಯಾಕ್ ಆಗಿ ಡೆವಲಪ್ ಆಗುತ್ತೆ, ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ದ ಎಂಬ್ರಿಯೋ ಸ್ಯಾಕ್ ಆರ್ ಫೀಮೇಲ್ ಗೆಮೆಟೋಫೈಟ್ ಅಲ್ಲಿ ಏನೇನು ಇರುತ್ತೆ ಅನ್ನೋದನ್ನ ಈಗ ನೆಕ್ಸ್ಟ್ ಸ್ಟಡಿ ಮಾಡಿ. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಮೆಗಾಸ್ಪೋರೋಜೆನೆಸಿಸ್ ಅಗೇನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ 5 marks. Okay, what is megasporogenesis? ಅಥವಾ explain megasporogenesis with a neat label diagram. Diagram ಬರೆದು 5 marks 5 points ಅಲ್ಲಿ explain ಮಾಡಬೇಕಾಗುತ್ತೆ. Is that clear? So, okay. Next, we will go for development of an embryo sac or a female gametophyte. Embryo sac, it is also called by one more name, that is female gametophyte. Okay, write down next heading. Formation of embryo sac or female gametophyte. This is two-celled stage. Write down. So I'll write the mature embryo structure after this one. Okay. So if I write here, it may not properly seen you people, I think. Okay. So write down this first. I'll explain this and later I'll write the diagram of the matured embryo sac. Again important for 5 marks. Okay. Is it visible? Oh, so let's see the explanation of this diagram first. Okay, so this is how the embryo sac formation or female gametophyte formation takes place. Very first, among the 4 functional megas, among the megaspores, only 1 megaspore will be functional, but remaining 3 will be degenerated. Hence, a single megaspore involves in the formation of an embryo sac or a female gametophyte. Okay, so this is how very first a single megaspore divides. Inside that, a pre-mitotic division takes place. Bari nucleus matra division. Okay, so pre-nuclear division takes place first without immediately following by the what? Karyokinesis only is taking place here, not immediately following by cytokinesis. Bari nucleus matra divide ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Pre-nuclear division ಇಂದ ಅಲ್ಲಿ ಸೆಲ್ ಫಾರ್ಮೇಶನ್ ಆಗೋದಿಲ್ಲ. ಬರೀ ನ್ಯೂಕ್ಲಿಯಸ್ ಮಾತ್ರ ಡಿವೈಡ್ ಆಗಿ ಡಬಲ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಬಟ್ ಸೆಲ್ ವಿಲ್ ಬಿ ದಿ ಒನ್ ಸಿಂಗಲ್ ಲಾರ್ಜ್. ಓಕೆ, ಸೊ ಸಿಂಗಲ್ ಮೆಗಾಸ್ಪೋರ್ ಫಸ್ಟ್ the nucleus will divide and forms the 2 nuclei. Okay, so the condition of the megaspore is said to be 2-celled stage. Next, these 2 nuclei again divide to form 4 nuclei. Hence, the condition of the megaspore is said to be what? 4-celled stage. Again, next, the 4 nuclei will involve in the formation of again doubles and involves in the formation of 8 nuclei inside a single large cell. Okay, so this condition of the megaspore is called as what? 8-celled stage. So after this, it will not follow again to form 16 nuclei. It will stop there. Later on, after the formation of 8 daughter nuclei inside a single large cell, then afterwards cell formation takes place. Okay, so let's see which type of cells are forming inside the megaspore. So very first, 3 cells are formed at the microphylar region. Among them, 2 cells are called as what? Synergies. And a single large cell is called as what? Egg, which is nothing but what? Female gametophyte. So female gamete, inside the female gametophyte. Again, so 3 nuclei are distributed here inside the 3 cells, 2 synergid and 1 egg. So totally, these are totally called as what? Egg operators. ಇದು 3 cells ನ ಸೇರಿಸಿ ಏನಂತ ಕರಿತೀವಿ ನಾವು? Egg operators ಅಂತ ಕರಿತೀವಿ. ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್, ಮಧ್ಯದಲ್ಲಿ 2 polar nuclei ಹಾಗೆ ಇದೆ. Remaining 3 nuclei are forming as antipodal cells. Remaining 3 nuclei ಏನಾಗ್ತಾ ಇದೆ ಇಲ್ಲಿ? Antipodal cells ಆಗಿ ಫಾರ್ಮೇಶನ್ ಆಗ್ತಾ ಇದೆ. So this is the diagram of developing embryo sac. This is not fully mature developed embryo sac, but developing embryo sac diagram is. Okay, so now I'll write the matured embryo sac diagram. Okay, I'll erase these 3 things and I'll write the matured embryo sac diagram here. That's what will be asked in the examination for you. Matured embryo sac diagram. The light little bit larger so that it will be visible for you people. Okay, so you people need not writing this much big diagram. See how you have to start the diagram. ಹೇಗೆ ಬರಿಬೇಕು, ಎಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕು ಅದನ್ನ ಫಸ್ಟ್ ತಿಳ್ಕೊಳ್ಬೇಕು. ಆಯ್ತಾ? ಬರೆಯುವಾಗಲೇ ನೋಡ್ಕೊಳ್ತಾ ಇರ್ಬೇಕು ನೀವು. Very important diagram for 5 marks. I'll repeat, you people need not to write this much big. ನಿಮ್ಮ textbook pages ಗೆ ಕರೆಕ್ಟ್ ಆಗಿ ಕಾಣೋ ಹಾಗೆ ಬರ್ಕೊಳ್ಳಿ. In order to make you people visible, I'm writing little bit large diagram. Okay. This is how this is developing embryo sac of female gamete. Fine. This is fully matured, developed embryo sac. Okay. Matured embryo sac. Diagrammatic representation of a matured embryo sac. Okay. Labeling will be like this. These three are antipodal cells. This is central cell. These two are polar nuclei. Egg. Synergids. Filiform apparatus. This one. Blue color structure. This is called as what? Finger-like projections. Filiform apparatus. Okay. Next, this end is called as micropylar end. Exactly opposite end is called as what? Chalazal end. But here we have written reverse. Okay. This is chalazal end and this is micropylar end. In matured embryo sac, it is opposite. This is micropylar end and this is chalazal end. Don't get confused again. Okay. Wherever the synergids and egg is there, that end is called as micropylar end. And wherever the antipodal cells are there, that end is called as chalazal end. Yeah. Okay. Write down the diagram. Very important for 5 marks. Explain the structure of a matured embryo sac with a neat labeled diagram. So you have to write the diagram first with the proper labelings and then you have to explain each and every cells of the embryo sac. Okay, write down. Okay, make a correction on the last diagram. What I have written? I have written 4-celled, 2-celled like that. It is not cell, it is nucleate. Okay, make a change in that. I hope I have written cell, I think, isn't it? Make a change, erase that 2 nucleated stage, 4 nucleated stage. Atara barkoli, that is not the cell, a single cell consisting of 4 nuclei condition. Okay, make a correction and write down this diagram. These two, egg and synergy, together called it as egg apparatus. Let's start with the explanation of a matured embryo sac. The matured embryo sac consisting of 7-celled, 8-nucleated condition. Okay, what is that? 7-celled, 8-nucleated condition. The embryo sac is called as 7-celled, 8-nucleated embryo sac. So, which are the 7 cells what we can found here? See, this is the central 1 long cell, 3 antipodal cells, 2 synergy and 1 egg. There is nothing but female gamete. Okay. So, how many cells have formed? 1, 2, 3, 4, 5, 6, 7. So, how many nucleus are there? See here. 1, 2, 3, 4, 5, 6. This is not fused. Okay. So, this is diploid polar nuclei which are retained as it is itself. 2 nuclei condition itself. So that's why the number of the nuclei will become 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's why the matured embryo sac is called as 7-celled, 8-nucleated condition. A single large cell, central cell consisting of 2 diploid polar nuclei which are not fused with each other. They are separated. Okay, so this is why the matured embryo sac consists of 7-celled but nucleated condition is 8. It consisting of 8 nuclei. So let's see how the formation of this one takes place. Okay, so these 3 antipodal cells will be present at the chelacal, and this is how the developing embryo sac will be get turned as a matured embryo sac. Next, at the micropyloid, we have 3-celled stage that together called as what? Egg apparatus. This egg apparatus consisting of 1 single egg cell, nothing but female gamete, and 2 synergy. Okay. Next, these antipodal cells are present at chelacal end, and how many number? 3 in number. So the function of antipodal cells is not exactly known till now. Till now, the function of the antipodal cells are not known, but they will be formed in the structure of the embryo sac. Okay. Next, as soon as the stigma, remember the structure of the pistil. Okay. So receptive part of the pistil is called as stigma, which receives the pollen grains. Okay. So this pollen grains will be undergoing certain chemical interaction, and if it is a suitable pollen, then it will form the pollen tube and transfer its male gametes into the stigma. Then through the pollen tube from the stigma, it enters the style and finally enter the ovary. In the ovary, it will enter the matured embryo sac. Okay. So while coming, the pollen tube first enters the synergy. Here, the finger-like projection, so-called filiform operators, will guide the pollen tube to move towards nearer to the egg apparatus. Then, the pollen tube moves towards the egg apparatus and releases the male gametes there. Their fertilization takes place and results in the formation of zygote. Okay, so this is the main function performing by the synergy as well as filiform operators of the synergy. So what are filiform operators? 1 mark question. Filiform operators are the finger-like projection found inside the structure of the cell called as synergy. So what is the function of that? It guides the pollen tube towards the egg cell. So this is the function of the filiform operator. Very important question. So many times it has been asked in the examination about filiform operator. Okay. Next, what's the function of the antipodal cells? Still not known. So, okay, here, what's the function of the polar nuclei? This polar nuclei here, remember, 2 male gametes are forming inside the pollen grain. Okay, generative cell involves in mitotic division and involves in the formation of 2 male gametes. One of the male gametes fuses with this egg and forms the zygote. But remaining 1 male gamete will be there free. So that male gamete fuses with the polar nuclei and forms a tissue called as endospermic tissue. Which tissue? Endospermic tissue. What's the function of the endospermic tissue there? Which nourishes the developing zygote or embryo. Okay, so this is how the structure of the matured embryo sac look like, and with the individual functions of the each and every cells of the matured embryo. Yeah, what is that inside the structure? 7 cells are there, 2 synergy, 1 egg, together called it as egg apparatus, and 2 central large cells, 3 antipodal cells. These are the 7 cells what we are observing in the structure of the matured embryo sac. Whereas the nucleus is 8. 1, 2, 3 diploid 2 polar nuclei, remaining nucleus of the 2 synergy plus 1 egg, total 8 nucleated condition. Function of the antipodal cells are not known exactly till now, but the filiform operators of the synergy involves in guiding of the pollen tube towards the egg apparatus during the fertilization. Okay, so 2 male gametes are released to the pollen tube. 1 male gamete fuses with the egg to form the zygote. Remaining 1 male gamete fuses with the diploid polar nuclei and forms the endospermic tissue. Okay, so this endosperm nourishes the developing zygote to form the embryo. Is that clear? Okay, this is the structure of a matured embryo sac. It's also called by one more name, that is what? Female gametophyte. Okay, so till now we have discussed in detail about what are male reproductive part of the flower. So how the male gametes are forming inside that, what is the structure of that, in detail we have discussed, and what are female gametes reproductive part of the flowers are called, and what is the structure of them, how they involve in the formation of a female gamete. Okay, the next concept of this chapter is how diffusion of male and female gametes takes place and result in the formation of zygote. How the pollen grains are carried and fall on the structure of the stigma, how it happens. Okay, remember, plants have a peculiar type of a sexual reproduction where both the gametes are non-motile. Okay, so usually one of the male gamete will be motile and remaining one will be non-motile. But in case of plants, during sexual reproduction, the gametes which are formed, both are non-motile. Hence, plants come across with a special mechanism in order to transfer male gametes nearer to the female gametes inside the female gametophyte. Okay, so that mechanism is called as what? Pollination. What is that? Pollination. That is the next concept of the chapter, so-called sexual reproduction in flowering plants. Okay, so ಈ plant sexual reproduction flowering plants ಅಲ್ಲಿ ನಾವು ಸ್ಟಡಿ ಮಾಡುವಂತ ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಯಾವುದು ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ? Pollination. What do you mean by pollination? The mechanism of transferring of male gametes through pollen grains from either the same flower or of the different flowers. Either of the same flower or of the different flower by a special mechanism known as what? Pollination. Okay, so there is a different types of pollination process are that we are going to study in the next class. Pollination andre ಏನು, ಹಾಗೆ ಎಷ್ಟು ಟೈಪ್ಸ್ ಆಫ್ ಪಾಲಿನೇಷನ್ ಇದೆ, ಯಾವ ತರ ಪಾಲಿನೇಟಿಂಗ್ ಏಜೆಂಟ್ಸ್ ಅಲ್ಲಿ ಇನ್ವಾಲ್ವ್ ಆಗುತ್ತೆ ಇಲ್ಲಿ ಅಂತ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡೋಣ. ಓಕೆ, ಸೊ ರಿಮೆಂಬರ್ ಟುಮಾರೋ madam is not taking this class, TG ma'am is not taking the class, I'll only take the class. Okay, then that I'll show certain PPT presentation for you people if possible. Okay, if possible I'll show certain PPT presentation for you people regarding the syllabus what we have discussed till. Okay, so hope the PPT presentation will be useful for you people to understand the concept till better. Okay, in the next class we will do that. Which one? In tomorrow classes. In the next class, in the following classes, so many these things are coming. How many of you will come for the offline or not? We doesn't know that. After that, it will be continued for you people in the next classes, further class. Okay, till that we have finished nearly half of the portion about in detail discussion of male reproductive part as well as the female reproductive part, formation of male gametes as well as formation of female gametes. Okay, so go through all these contents and then make a notes of your own, or else you underline the things in the textbook, go through the content. If you have any doubts, you can clear the doubts. Okay.